Hello, hola, hola. So, it seems that Paloma is busy at the moment, so I will just introduce our session chair, Nicolas Tabarot. So, Nicolas, the mic is yours.
Thank you. So, welcome to the second session of the day. So, this one is about breakthrough in computing, and it's my pleasure to introduce the first speaker of the session, Felipe Tobar. So, Felipe did his PhD at Imperial College in London, and then he did a postdoc at the University of Cambridge, and he's now assistant professor at Chile, and also director of the, we say, IDEA in Spanish, I guess, Initiative for Data and Artificial Intelligence, also part of Chile. And Felipe is working on at the frontier between machine learning and signal processing, and so he will be presenting two models on time series. So please, Felipe.
Thanks very much for inviting me. It is a pleasure to be here. I'd like to start congratulating the team. It is quite an effort to prepare something like this, 4 days, 4 universities, 3 cities. So congratulations for achieving this to all the team, Nayat, Luis, Julia, and everyone, all the team. Today I'm going to talk about a couple of works we've developed over the course of the last, I'd say, 5 years. So the first one was developed actually 5 years ago, and the second one is ongoing work. We've been working on that this year with Chris, my co-author, who is there. And these models are for multiple time series. Okay, so I'd like to start talking about the process of learning from data and the need of models to do that. When we do machine learning, when we use data to train models, what we're trying to do is to understand the world, and the world comes to us only through corrupted and partial observations, which we call data. And data is incomplete, data has problems, and the model we develop connects the real world, which is latent for us, to the world we see, which is data. So hopefully we build good models that are representative of the latent state of the world. In particular, the two models I'm going to present today are time series models. And the reason I'm interested in time series is because they are found in several fields, ranging from finance, audience, seismics, to fault detection, public policy, and telecommunications. So there are multiple scenarios where we can find time series. And in each specific scenario, there are multiple tasks we can perform for time series. Most of the work I'm going to be presenting today are about imputation. So estimating or predicting the value of the time series at a certain timestamp. But there are other applications too, like control synthesis, interpretability, estimation, spectral estimation, extrapolation, interpolation, denoising. The notation we're going to be using throughout the talk, the graphical notation, is every time you see like a noodle or a spaghetti like this, that means latent. So that actually I'm not seeing that. I'm only seeing the dots. And throughout the presentation, you will see different signals and different dots with different colors. But every time I show something continuous, is latent, is unknown to us, but we only see the points. And one extra motivation to talk about models for time series and models in general for this slide is how do we choose the complexity of the model? Training a model from data can be seen as a sort of compression. So you get your big data application with terabytes of acquisitions, and then you want to train a model. And hopefully the model weighs less than the data set. right? So it's a way of compression. And the question, and with that compression, you should be able to achieve whatever you achieve with the whole data set. You can store the data, you can draw inference from the data, predict values at the data points. And the question of how complex should this compression be, or how complex should be the model, is important, and it's important for this talk, because the models I'm going to show are of two different nature. Spoiler, the first one has infinite parameters, and the second one has way too many parameters. So we're going to assess the difference between the two concepts. And there are key questions in this regard. For example, how complex should the model be to work for my application, and if the amount of data really determines the dimension of the parameter. Okay, so we will start with a very basic model. I am sure this is known to everyone here, but this is probably the simplest model we can think of, parametric model, which is the linear regression. In linear regression, we want to learn the relationship between two variables, and we assume the relationship is linear. So that boils down to finding one parameter. So say that our input is t, because it's time series, and our output is x. That is the notation for the process we want to discover. And the simplest way we can do is to produce a linear model, which is the model in blue here, and that interpolates a single line that hopefully goes very, very close to our data points. There are different measures of proximity. There are different approaches to do this, and the classical one is least squares, which is this one. And the way we use this model, even though it's very simple, is because it has closed form. This functional as a function of theta, which is the model, is convex. That means that the solution of this problem is unique, and we can find it via this expression. In practice, this in this vanilla form is not too useful, because, for example, if we want to perform regression on a data set of images, the assumption of linearity doesn't make any sense. It is very difficult to find whatever quantity that relates to the images only from a linear combination of the pixels. So what we do in practice is we use features. So rather than implementing the model linear in t, we implement it as linear on a nonlinear function of t, which is called the feature. Now, even though this model might have parameters, when I'm learning the parameters, I fix the parameters of the feature. So it's usually called a handcrafted feature. And parentheses, sometimes it is difficult to because there's lots of buzzwords in the field. So machine learning, deep learning, data science, blah blah. Sometimes it's difficult to state the difference between these topics. But somehow it is natural to think that when these features are handcrafted, we say it's machine learning, and when it's automatically discovered, it's deep learning. That is it's open to discussion. But that is one way of putting intuition here. Now, as this model is still linear in the parameter, it's non-linear in the input, but now it's linear in the feature and the parameter, the solution is still unique because the cost is still convex. So in practice, we do this. We use linear models, but in a non-linear transformation of our input. Now, with this model, it's motivated by the simplicity of this model, let's see how we can generate data using this model. And that's what we can call generative linear regression. So basically, we have the same linear model. Now, notice that I wrote the feature as a sum of the features rather than an linear product as here. And we can generate random functions by setting the features. So for example, this could be sine waves, or could be polynomials, or piecewise constant functions like steps. And we can produce random values for the parameter, and this is the illustration of this concept. So first we have the phi's, which in this case are localized, but they don't have to be localized. They could be, for example, polynomials. These are the random weights, which here are sampled as a uniform 0, 1. And then we do a pointwise product of all of these. And we have a weighting for the basis functions. And then we sum them all and have an interesting signal. Then we can use that signal to model a time series. Now, this question, to me at least, it naturally arises. How many functions should we use so that the model is expressive? And it is natural to think that the more, the better, basically. Okay? So I would like to take this concept further and basically convince you that we can take an infinite number of bases. Okay? And there are two approaches to do that, and both of them are based on kernels. The first one is the support vector machine, which finds these functions in a very specific Hilbert space, which is called an RKHS, a reproducing kernel Hilbert space. We're not going to refer to that way now. We're going to refer to another one, where we use an infinite number of bases, but we integrate them out. So we forget about them and only learn about their statistics. And how do we do that? First, we can observe that this model, if theta is random, is a Gaussian process. And it is a Gaussian process because it's just a sum of independent Gaussians. So it's a very simple statistical model. And as a Gaussian, it is described by their first two statistics, so the mean and the variance. The mean is 0, doesn't have to be 0, but let's leave the mean out of the question for now. Let's focus on the covariance. This covariance is the inner product between the features. And this is when it starts becoming interesting, because how can I design very expressive Gaussian linear models by choosing a phi that is super, super high dimension, eventually infinite dimension? And for that, there is a theorem that is the Mercer theorem that says that if a kernel is positive definite, a kernel is just a symmetric function that goes to R, so it takes 2 points in the time space. For us could be a space, but for this talk is for time. So it takes 2 inputs and gives you a scalar. If that function is positive definite in the sense that a matrix is positive definite, there is an expansion for this function of this form. So basically, if this K is positive definite, there is always a feature that, when I do the inner product with itself, gives me the kernel. So that gives us a way to bypass completely the choice of the phi, the feature, and only choose the K. Because if there are certain Ks, there's a library of Ks that are related to infinite dimensional phis. And that's what we're going to do today. We're going to build a model like this, but that implicitly has an infinite dimensional phi. So I'm looking for theta in an infinite dimensional space, but I'm not going to target the design of phi. I am going to target the design of inner products of phi. And in any algorithm that is completely presented as a computation of inner products can be kernelized. And that happens with regression, and that happens also with support vector machines, and with PCA as well. You can have kernel regression, kernel machines, and kernel PCA. Now, with this we have the Gaussian process. The Gaussian process is a stochastic process for which any collection of points is a multivariate normal. It is good because it's infinitely expressive. One can prove that depending on the K, but in general for many Ks, the paths that are generated by this construction is arbitrarily close to any continuous function. So basically, I have a model that can get arbitrarily close to any function that I want to approximate. Now the cost is that as I get arbitrarily close, it gets increasingly expensive. But we're going to overcome that. This is a crash course on Gaussian processes. When you want to implement a Gaussian process, you have to do 3 things. The first one is to design, or the choice of the kernel. One attractive things of Gaussian processes is that you can encode your inductive bias in the choice of the kernel. For example, if you have smooth functions or functions with long-term correlations, or periodic functions, or periodic function or harmonic functions, there is one kernel for each one of these functions. And then if your function has multiple characteristics, you can even sum them together. So the first thing to do is to choose the type of kernel you want. Now, these kernels are still defined by some hyperparameters. For example, what is the range of the correlation? What is the frequencies at which this oscillates? And then you can optimize the kernel via maximum likelihood. And one interesting thing about this model is that even though the model is infinite dimensional, in practice you only see a finite set of data. And the likelihood, which is the, if you want the performance index of your model, only depends on the finite amount of points. So you can still optimize in finite space, even though the model is infinite dimensional. And then when the model is, when the kernel is chosen, parameters is chosen too, you do it via using stochastic gradient, for example, you get your posterior predictive. That means that you give an input, a new input time, and the predictive posterior distribution is completely defined as Gaussian by these moments. And in function space, this looks like this. So you start with a Gaussian process, with the prior Gaussian process that hasn't seen any data, which gives you a very wide measure over the function space. But then as you add more and more data points, this measure concentrates on, hopefully, the real function. So basically, it reassigns all the probability mass to a region. And in the sample space, it looks like this. When the process hasn't seen any data, any trajectory is possible. But after you see data, which is the red points, all the trajectories are still aleatoric, but they have to go through the data you've seen. So they work as restrictions. Here, the band denotes the 95% confidence interval. This is an example. This is a heart rate signal, 1,800 data points, 15% of observations. This is a specific Gaussian process with a Gaussian covariance. That means that I am saying that points that are close, they covary. Points that are farther away have a covariance that vanishes exponentially. And when I implement the Gaussian process with this data, I see that the confidence intervals are a little bit odd. And that is because the Gaussian process is not trained. It hasn't learned the temporal correlations, but when one optimizes the likelihood function, those dependencies are learned via, again, gradient descent on this cost function. And then we see that the prediction band, which is the light blue section, is much tighter to the true process. Now, this is all well and good. This has been this has been happening in the Gaussian processes community in machine learning, I'd say, since the 2000s or 1990s. The method was also developed a little bit earlier in the geostatistics communities. It was referred to as kriging. And also there are kernel methods called similarity-based modeling that come from engineering that share the same concept. So this signal is discrete and is it consists of 1,800 data points, and for training I'm only using 15%. So the true points is the 85% of the points that I haven't seen for training. But today I am interested in multivariate processes and how we can extend the concept of Gaussian processes to multivariate signals. Multivariate signals are challenging because one needs to mine relationship not just across time, but across channels as well. And all the attractiveness of the Gaussian process where one encodes inductive bias in the correlation is difficult to translate to this case, because it is very difficult sometimes to naturally understand what should be the correlation for different measurements. Probably in this case it's not too much because they are all electrodes in a scalp, so they should relate more or less in a consistent way. But if you have measurements in a sensor network where one is, for example, temperature, pressure, speed, blah, 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 it is not clear how they should relate to one another, on top of deciding how they relate in time. So the naive application of implementing an independent Gaussian process per channel doesn't exploit the relationship that's inherent to the application. We are going to take the same stand. We're going to assume for our multivariate data that the Gaussian process is a good prior. It's still the same definition. All the points in a multi-output Gaussian process model are related by a multivariate normal. That is the same. This is the same assumption for the model, or even for the implementation. It doesn't matter if the points come from a single signal or multiple signals. When one can properly design the covariance. But the problem remains, how can one properly design the covariance? Again, for single Gaussian processes, we can try different covariances, but when we have multiple signals, this this combination of multiple channels needs to be discovered in the same way we discover the parameter of the kernel. But when we have a single kernel, we have a continuous range for the parameter. But in this case, we have multiple types of covariances that we need to find. And the object we need to find is this. This is an illustration. It is a cube where that has a continuous dimension, which is time, and has two discrete dimensions, which is the channel. So for each timestamp, we need to find a matrix that defines the multivariate normal distribution that governs all the observations at a single timestamp. Or in a different way, for every pair of channels, we need to design the hebra, the thread that goes inside this cube. And there are many conditions that this design needs to fulfill, and they are mainly positive definiteness in all three axes. So one in continuous time, and the other two in discrete space. One way to overcome this problem is via reparameterization. So anyone working on machine learning probably has heard the reparameterization trick in multiple works in the last few years. And reparameterization is a common practice in machine learning because in the field we don't like constraint optimization. We don't like optimize things that has many boundaries. So we reparameterize so that we design in a space that is unrestricted. And one way of doing this with covariance functions is via a theorem that is called the Bochner theorem or the Wiener-Kingen theorem, which says that any correlation function is the Fourier transform, so the anti-Fourier transform of a positive measure. And the intuition behind this is very clear. This theorem links the representations of the representation of the signals in time, so how they correlate in time, if they go, if they are correlated at long or at short or long distances, with another representation which is equivalent, which is the energy that the model assigns to each frequency. So if a model oscillates quickly, all the energy of the model should be spread in high frequencies. And the opposite is also correct. Now, this has been introduced in the Gaussian process community now 10 years ago. And our intuition was that this can also be translated to the multi-output case via the multi-output counterpart of the theorem, which is called the Cramer theorem, and says that now if I have a family of covariance functions, then there is a family of spectral densities that they also have some restrictions, but the critical restriction, which is the positive definiteness in time, vanishes and is ensured when you perform the anti-Fourier transform. And that's why I meant by reparameterization. I am no longer defining the covariance, I am defining the energy. Okay, and the energy has one extra degree of freedom that is ensured after I produce the Fourier transform. Now, still, there is some restrictions I need to fulfill. So I do an additional reparameterization, which is the very basic one, which is the Cholesky decomposition. And to fulfill the positive definiteness of the spectral energy, I just define a set of unrestricted functions. This could be any function. When I do this Cholesky trick, which is actually the inner product with itself, it becomes positive definite. And when it's positive definite in space, the anti-Fourier transform gives me the positive definiteness in time. And just a brief comment about these functions. I don't know if there are some electrical engineers here, but of course they are. But these functions are the impulse response of the system. So we're becoming so far reparameterizing that we reach the dynamical system representation of the time series. This is the impulse response, or what's the other name? Forgot the other name. Okay, a transfer function. It's the transfer function of the system. And the covariance we built have this form. if you choose R to be a sum of Gaussians, you have this expression, and this is the covariance you can generate with this model. So you can say that different channels oscillate at a peak at 0, and then they perform a few oscillations and then vanish, which is fine because in time, at some lag, the channels need to decorrelate. But as this is defined in the complex domain, you can represent delays. And one key feature of this model is that it can naturally represent time delays between the channels, which makes sense for anything, for any network sensor that is affected by an impulse, and then it propagates through the net. Now, how does it work? This is an example for financial series, where we can see that the black dots are the true, sorry, the dashed line is the true data, and the black dots are the training data. And all the bands you see in light red are censored ranges. And then we train the multi-output spectral mixer, which is the name of the kernel, and we can see that we can perform imputation. The color bands are the predictions. There are some of them that are more difficult than others, especially when you miss many of the currencies. And then as a byproduct of training this model, you get the correlation matrix, and you can see, for example, that Hong Kong dollar is highly uncorrelated with the Japanese yen. What else? You can see that Australian dollar is highly correlated with the Canadian dollar, and so on. Same model, exactly the same model, can be used for electroencephalography. This is the same experiment. 16 channels, all light red bands represent sensor disconnections. And the objective of this experiment was to identify if a sensor that is detached from the EEG can be reconstructed from neighboring nodes. And we can see that, for example, C3 is more or less reconstructed. We can see that F4 is maybe reconstructed better. O2 is reconstructed very accurately. And that depends on how many neighbors they have. So, for example, O2 is probably the best reconstructed one because it's surrounded by nodes that are not disconnected. But when you have clusters of disconnections, of course you lose the information because these nodes share firing neurons. So if you miss a set of them, you will miss that phenomenon. Now, training this model is super challenging because when the kernel is like this, when you input this kernel in the likelihood function, there's multiple local minima and there's also invariances. So, for example, which channel goes ahead of which channel. And the problem is that we were very happy with this model, but people weren't using it because no one could train it. No? Only we could train it. So we developed a toolbox that is called the MOGPT-case, the Multi-Output Gaussian Process Toolkit, that is based on PyTorch, and it was developed during the course of 2019-2020 together with Taco and Alejandro. Taco at the time was an engineer at a data engineer at CMM, and Alejandro was my student from the Department of Elec Eng, and then the Department of Mathematical Engineering. We worked on this, and it was quite a challenge because the challenge wasn't related to our specific model, it was related to handling multi-output GPs. So after we achieved that, we not only coded our method, but many other methods so that it could be used as a benchmark. It was envisioned for reproducibility of research, and it was aimed at data scientists. So it has a full stack of tools to acquire data, show data, perform imputation before passing it to the Gaussian model. And it has an active community of users. It has almost 150 stars. People are following it. We usually get requests of adding new things. I wanted to show this because this was possible only because of the collaboration of these entities. So we started doing it at CMM. Then Taco moved to Inria. We continued working on it. And and was consistently, of course, supported by grants from ANID and Google. So it's a very good example of collaboration and public investment science. This is the team. Taco and Alejandro are the main developers, and these are my students that work based on the toolbox for different applications, for EEG, for finance, and for non-stationary extensions too. The toolbox is available if you want to go and visit the website. It's hosted in GitHub. It has a very broad documentation, tutorials and examples that we continuously update, and it has 45 citations. That doesn't sound like much, but for software that means that a fair share of those citations are using the toolbox, which I think is key. More than the citation is that people are using it. Now, let's go back to the problem of modeling the time series. Let's now visit another model. So remember that we have multiple signals, we have observations of the signals. Let's forget about the signals. Let's only talk about the observations for 1 second to derive, as I say here, a graph representation of the Gaussian process. So we get the observations, we get the data points. In practice, we don't have this. In practice, we have this because computation is finite. So we cannot host an infinite dimensional object in our computers. And the Gaussian process establishes relationships between all possible observations. And that is good because it's expressive, but it's also expensive. When you perform prediction, all the data points needs to be revised to perform a single prediction, and that is very expensive. It's a fully connected graph, so it has the order of complexity is n squared for execution, which is expensive, but even worse is n cubed for training, because inverting the covariance matrix is of cubic order, and that is the main drawback of the Gaussian process. And in its vanilla form, that means that you cannot process more than 2,000 data points. So if you're talking about audio samples at, say, 192 kilohertz, so that it's 1 millisecond of audio. So you cannot do anything. It's not even a phoneme. Another drawback of the Gaussian process is that the connection is too basic. The connection in the graph. So when you have all the data points and you want to perform inference of a new point, the mean is just a linear combination of past values, which is linear, because I build the model from the ground being linear, right? And it's also bilinear in the features, so it's a inner product between the historical features and the new feature. So we would like to, inspired by this construction, to produce an architecture that is more expressive, okay? And for that, I will follow my longtime mentor Pablo, and I also use transformers. So this paper, so we're gonna share 2 slides, Pablo. So this paper was presented in 2017 as a culmination of the usefulness of this concept, attention, and is originally presented for text, right? You input a sequence of text and then input another sequence of text, and then you do predictions, and that can be used for next word prediction, for translation, and so on. Okay. Now, what is this? What is this attention? That's happening inside the transformer block? Basically, you take your words in text or nodes in time series. So the node is the value of the node, but it also has richer information like the timestamp, the ID of the channel, the regime. So all the information you can put it there, and then you map that object to 3 high-dimensional spaces and perform an inner product, just as the Gaussian process does, and then apply some nonlinearities, and then go again through the same block, and then to a multi-layer perceptron, and that in turn finds how different tokens relate to different tokens, and that is exactly what we need for time series as well. Now, although this is also based on an inner product structure, the inner product occurs in all the components of my observation, not just in time. And that is the main drawback of the Gaussian process. It only maps time to an infinite dimensional space, not the value. So let's go again and let's introduce some ideas to how we build this graph. So this is the same animation I showed for the graph being built from the Gaussian process, but with some differences that will lead to a different architecture. So again, we have our data, we have observations. Let's forget about the lines because otherwise the diagram becomes too complicated. And I'm going to denote a point that I want to predict. So circles are data, star is unknown, the place where I want to perform the prediction at that time vertical and that channel horizontal. The first thing would be, in blue, to embed all the data into a higher dimensional space. We use dimension 16. So embed time in this higher dimensional space, embed channel number to this high dimensional space, embed the value of the point to this dimensional space, and any information you have from the acquisition, you can embed it into this high dimensional space. Then perform a graph encoder, which is basically, more or less, it's not the same, but it's like the first part of this block. Okay? Graph encoder. And one decision we took was to do a causal mask. So we only harvest relationships that go in the flow of time, because we're assuming that somehow there's some causality in the time series. That's not needed for text. Okay. Of course, the model would be more expressive if we wouldn't put this constraint, but this facilitates things in terms of computational complexity. Then do the second part of the architecture, which is the generator. Take all the all the embedding passed through the attention process, and then perform a transductive node generation. That means creating a new node with the query, which means where I want to identify the value of this node, and use the entire graph to predict that point. The architecture looks like this. A draft of this article is posted in the archive, and it's similar to the architecture you saw. So basically you have data points here, historical data points, and places where you want to predict. And first you embed everything, time, value, and all metadata with temporal embeddings that are learned. So this is everything that is green in this neural architecture is trained. So you have temporal embeddings that are learnable, metadata embedding that are learnable, and value embedding that are learnable. Then you concatenate all these vectors and pass twice through this transformer. So you do the mask attention, concatenate via summation, normalize, go through an MLP, a multi-layer perceptor, and go again twice. And then with this richer representation, you do exactly the same but comparing with the target. Do once again and then perform prediction. The way this is trained is by looking at the data points, taking all the data points, arranging them like this, and taking chunks of the data points to build these smaller graphs. So basically, the first three data, in this graph, red means unknown. So basically, I am removing nodes of my data set, and I'm going to force a common structure to predict randomly censored nodes. And I'm going to force that the architecture that is used to learn this prediction is always the same. So and that the aim of that is to have an homogeneous graph that operates in all the regions of the signal space. And basically each of this arc is this architecture entire. In our experiments, we use a context length of 100 data points. So 100 data points more or less are used to predict one point. And for the choices we made, the model has 378,000 parameters. Preliminary results are tested on these benchmark data sets that are known, the UCI, the FusionNet, and Beijing. And we perform a sensibility analysis for data removed. So we recreated different regimes where we have from 10% to 90% of removed data, and compared against a naive mean approximation, Gaussian process, variational autoencoder, and the state-of-the-art in graph neural network for time series. And the AGG, which is our model, is called the asynchronous graph regenerator, outperforms all the models in these data sets with a critical improvement over the state-of-the-art. So now, to close, we are very enthusiastic about these results, and beyond the results, we're enthusiastic about the relationship between these two architectures. One has infinite parameters, the other one has, in the order, well, this could be identified as a prototype, but this can have the order of the million parameters. So it's infinite versus million parameters. No small parameter here. And we're very happy to continue to understand how these architectures relate, and critically if they can be blended, so that, for example, the architecture reconfigurates as a Gaussian process for small data sets, and then converts into the transformer for the large data regime, or how can be used the Gaussian process uncertainty quantification properties to endow the transformer with error bars. Thanks very much. That was my presentation.
Thanks, Felipe. We have time for a few questions.
All clear. Very good.
No, this is actually just a comment that we have a somewhat similar paper published a couple of years ago on graph-based transformers for doing something. It's funny because it's a similar problem, but in this case for weather forecast. So you have stations, and you need to, using attention, try to encode the relevance of different stations connected to one place. And so actually maybe it's interesting to do like a cross-reading of the papers, and would be really interesting. I just want to fully understand it. So,
yeah, thanks very much. The climate data is a good motivation for these models. The Beijing data set is that type of data.
So, yeah, I guess we have a new question.
Thanks for the great presentation. I had a question on the first part of your talk on single variate Gaussian processes. So you feed like non-regular data in time. Could you comment on the impact of regularity on the precision of the feed between the points? Because I mean the question is it better to have like regular data with a lower frequency, or higher frequency data but less regular in time? Because when you showed like this function, the gray area, the uncertainty, is it trivial to predict where you're going to have a huge uncertainty for the functions? Is it always in the gaps, in the places where you have few data?
Yeah, thanks for the question. Great question. I've been working on that for a few years because to me that's in the interface between Bayesian learning and Fourier signal processing. So training Gaussians is an ill-posed problem because you need to find more parameters than the data you have. You have n data points, you need to find n square covariances. So when implementing a Gaussian process, what you do in practice is you tie the covariance function together. So basically you introduce a very strong assumption on the covariance of the structure. And for n data points, you go from trying to find n square covariances to finding one parameter, which is the width of the kernel, for example. So when you have regularly sampled data points, that is not a problem with the vanilla GP because the covariance is so tight in time that you don't have uncertainties. But if you chose a very expressive covariance function, so for example, say your covariance function is not a deterministic function, you have a prior on covariances, and then you have uncertainty a long time for the covariance, there is one part that it will never be discovered, because if you have data points every t time steps, any frequency outside that 1 over t won't be discovered. And that is, to me, that is beautifully tied to the Shannon-Nyquist limit.
Okay, thank you for your answer.
Okay, so let's thanks Felipe again. So we now have two short session, short talks before the next coffee break. So the first talk is by myself, so I guess I will introduce myself. So I'm Nicolas Tabarot, as it's written here. I'm the team leader of the Galinet team in Nantes. So Galinet is a team working on Proof Assistant and mainly on the Coq Proof Assistant, which is a project developed at Inria mainly. And so I'll be presenting today my work, the work that I've been doing with Eric Tanter at Chile here, and this work has been, so we have a very long-standing collaboration, thanks to also to Inria Chile and to the support of Inria with the associate team. And so I will present our work on gradual proof assistant. So first maybe I will show a bit what are proof assistant and what they're made for. So maybe you know we have used them during your during school or maybe during your PhD. So there is the two main proof assistant based on type theory, or the Coq proof assistant at the top, and now the Lean prover that have been developed by Microsoft Research and now Amazon. And so these proof assistants are today quite widely used. So if you follow a bit the news on the subject, there have been already several strong results about software certification. So there is famous Concert compiler project with a C compiler fully certified in Coq, which is now, for example, used on Airbus airplane or this kind of stuff, and another big project in the US. And on the Lean prover side, so it's a bit less frequent to do a software certification with Lean, but there is a huge community on the mathematical library and formalization of mathematical proofs in Lean. And so they are quite widely used now. And how does it work? So on one side, you see what is a typical mathematical proof as you learn at school. And on the right-hand side, you have a typical program written in some language. And actually, the keystone of Proof Assistant is actually to consider that these two things are the same thing. And in order to do a proof for a computer, you can do a proof in a mathematical language, in a mathematical program. And really, the idea is that there is a strong correspondence between logic and program. And so the correspondence is at the level of formula, which corresponds to type in programming languages. And even more importantly, a proof that a given formula is true corresponds to a program that meets the specification of the type. And so based on this very fundamental correspondence, the Coq proof assistant and then the Lean proof assistant has been developed in a system for which the programming language is already at the same time a logical system. So it's really the same thing. Programming and proving is really the same thing in this system. And the nice thing with that is that it has been very useful to do some program certification. So I mentioned already the Concert compiler, the certified C compiler by Xavier Leroy's team. But there are also successes on the mathematical side. So there is the famous proof of the odd order theorem, which is a theorem for finite groups that was considered very difficult to formalize and has been possible with the Coq proof assistant. And so now the Coq proof assistant is quite a mature system. It got an ACM award and so on and so on. So we can wonder, do we still need to improve the system, or do we just have to use it now? And actually, it's not as ideal as it looks like, because it still has many weaknesses, and it's very hard to change how the system works, because as I said, it's at the same time a programming language and a logical system. So if you want to introduce a new programming facility in order for the user to be more easy to use, then you need to provide a logical correspondence of this new feature, so you cannot do whatever you want in the system, otherwise you can prove anything, and then it doesn't make sense as a certified system. So what are the limitations that we want to overcome and that are difficult to overcome? So one of the main limitations from a programming language point of view is that every function must be fully specified. And by this I mean that there is no case where you just raise an error. So if you look at the definition, for example, of the head function for a list, in any mainstream programming language, whether functional or not, usually what you do is that in the case of the empty list, of course there is no head to return, and you just return an error. That's perfectly fine function. But this behavior is kind of forbidden for proof assistant, because being able to return an error when you don't know what to do also allows you to return an error when you don't want to do the proof, and then the meaning of a proof becomes meaningless, because you can just fake your proof by raising an error. So having incomplete function is not accepted, and so the drawback of this is that in order to define the head function in a proof assistant, you need to provide enough preconditions so that the function is always defined. And in case you reach, so here you reach the nil case, instead of being able to raise an error, you do a proof that it's not possible. So here the precondition is that the length is not 0, and when you reach the nil case, you use this precondition to say this case is not possible. So in the end, you get the same, on the good cases, you get the same function, but as you can see, it's already very complex to define just the head function, because you need to make it fully specified. And another, I guess you can't really read, but another limitation from a programming language point of view is that every function must terminate, and the system needs to be aware of that. And so, for example, if you naively define the division function on an integer, you're doing a recursive call on n minus m, and obviously when m is positive, n minus m is less than n, but the system is not able to detect it, and the recursive call is not accepted, so you need to define your function another way. So as a standard software engineer, it becomes already quickly a nightmare to do this kind of stuff. And so the same limitation applies to all proof assistant. It's not specific to COC. And so the idea in the project that we developed with Eric Tanter is that we can reuse the idea of gradual typing in order to maybe leverage a bit the burden for the programmer to prove things. So the idea of gradual typing is to bring a gap between untyped programs, so let's say Python stuff, and fully typed program, which have more properties. But when you start from an untyped program, it's very hard to directly reach a fully typed program, because you have potentially million lines of code, and you need to modify everything so that it type checks. So the idea of gradual typing is maybe to provide a more smoother path between an untyped program and a fully typed program, and to allow the integration of both untyped and fully typed program, with the property that nothing can go wrong by losing type information. So if your program can be fully specified, then making it less precise will not make it go wrong. And so that's the idea of gradual typing. And the idea in our project is to leverage a bit this idea at the level of gradual verification. And so here, instead of type versus untyped program, we have certified versus uncertified program. And again, as a software engineer, it can be very costly to directly go from a fully, totally uncertified program to a fully certified program. And what we want to provide is facilities in order to make it possible to partially certify your programs, and still having a kind of graduality theorem saying that you will not lose certification by making it less certified. So the more you certify, the better. And so maybe just a course idea is that in order to make it possible, we introduce kind of notion of exception in the language. So as I said, exceptions are currently not allowed in proof assistant because they can be dangerous, but we have now ways to allow them without getting into trouble. And so the idea is to add new values to, for example, the set of natural number. Two exceptions, the one for being not defined, and the other one that comes from gradual tapping, saying that it can be any natural number. I don't know now, but later I can specify it a bit more. And the idea behind these two exceptions is that one is encoding the possibility of being a natural number, and the other one is rather encoding the fact that there is no natural number that corresponds to it. So I don't really want to go into detail here, but just to illustrate what you could do in our gradual certification framework. So let's consider the case of the filter function over list. So this is a function that takes a vector, or so a list of size n, and a predicate which element of the list must be pruned out of the list. So if the predicate is true on the element, you keep it, and if the predicate is false, then you remove it. And the problem is that if you do it in a fully certified world, you want to return a vector, so a list with its size, and you don't really know the size of the return list because it depends on how many elements will be kept by the filter function or not. And so if you start doing it as a naive programmer, you can be a bit intimidating by in order to do that carefully, you need to fully specify the size of the list by computing another function that will compute the size, and it's a bit difficult to do. And so what we provide here is, instead of providing a concrete natural number, you can provide the unknown, and you keep working with that, and then the system will dynamically check that your specification is correct, and in case your specification becomes incorrect, it will just raise an error. So if you start filtering the empty list, it will raise an error because some cast will fail. And if your filter function, so if you take the head of the empty list, it will fail. And in case your function actually, your filter function returns more than one element list, then the head function will compute. So you change somehow static specification to dynamic check. And then if you want to specify more, then what comes out is that you start having more static guarantee and less dynamic error. And the more you specify, the less you will have dynamic error in the system. So for example here, now, you can statically know that taking the head of the filter of the empty list is not accepted by the system. So instead of doing a dynamic error, you're doing a static type error. Okay, so this was just a quick look at the project we run with Eric on gradual certification. And maybe because the day and the session has been quite devoted to machine learning and artificial intelligence, I would like to conclude on maybe one of the major future challenge in proof assistant is maybe being able to use machine learning and deep learning in order maybe to leverage the burden of producing proofs for user by using a computer. So the idea here is that we could maybe mix proof assistant and proof generation in a nice way. So proof generation could be done, for example, by a ChatGPT or Copilot thing. So just system that propose a way to prove things. And because we have a proof assistant now, we have also a way to check that the proposal of the machine learning algorithm are correct. So on a concrete example, so here it's done in VS Code with Copilot. You start proving a lemma, and then the artificial intelligence is suggesting some proofs. So most of the time it comes from other libraries that prove similar things, or it can be done by more generative stuff. And then you accept the proof, and you try to compile it, and then the proof checker, the proof assistant, can check that the proof is actually correct. So in the end, you don't have to trust the artificial intelligence stuff, because the trust in it is only on the type checker. The proof that has been generated cannot be wrong because it has been type checked later. So we are in a setting where there is no issue with hallucination of the artificial intelligence. So for example, here is a modification of the lemma with a bit more complex lemma. And then the artificial intelligence is doing some kind of confabulation and proposing a proof that is not true, not right. But this is not really an issue, because then the type checker is able to detect that this proof is not correct. And so you can go back to the artificial intelligence to say, oh, this proof is not correct, please correct it, and you go it this way. And so because your specification is somehow complete, there is no issue with the wrong program. And so one of the questions of this field is that, can we use this tension between proof generation and proof checking to get a kind of virtuous cycle and get very powerful automatic proving done with a high level of trust? That I would like to discuss with people here, maybe during the dinner, about what could we do in this area. Thank you. We have time for one question. Maybe not. So and the next speaker can prepare also himself.
On the SQL query generation that you use for astronomy, my question, maybe this is a sort of a way of addressing this, because if you don't have a proof, but you also generate a possible proof, if two things go wrong, it's less likely. So maybe it's an interesting approach. So I never expected you will also be using transformers. Yeah. I don't know if you know, but transformers were a borderline accept in Neurips. The transformers paper was borderline accept in Neurips. It was actually a poster, not even a full paper. So and we all live out of it.
Okay, so let's move to the next talk. So you're the only one present. I didn't know if you were two people presenting or only you. Okay. Yeah, but you were written with together with. No. Maybe I'm wrong. You're Diego? Yeah? And Juan is not? Okay. Hold on, so that was my question. Okay, so Diego is doing a PhD at Inria Lyon and INSA about IoT for satellite communication. And so you're presenting a project called Stereo about how to use kind of low altitude satellite in order to connect them to IoT system and to get more widespread IoT system. So you can.
Hello, can you hear me? Okay. So hello everyone, thank you very much for being here present at my talk. My name is Diego Maldonado, as you mentioned. I'm a PhD student in Inria. And I'm going to present you today the Space Terrestrial Integrated IoT, or Stereo. This is the project under the guidance of Juan Freire, who is the project coordinator. He's my PhD advisor. So as the title hints, the goal of this project is the integration of terrestrial and space communications, so this is satellites. So our focus is on IoT, Internet of Things. So we have the problem that only 10% of the world's surface has terrestrial connectivity. This is access to electricity or internet. So there's still a wide area of the world that has no connectivity. So it's not going to be possible to deploy IoT networks so they can rely on internet as we want to in the paradigm of Internet of Things. So what can we do to solve this problem? The proposition is to use satellites as we have been doing since the 70s with the first communication satellites. So low Earth orbit satellites, which orbit at an altitude of around 400 or 500 kilometers above the Earth's surface, are going to be able to capture the packets from IoT nodes deploying inhospitable parts of the Earth, like deserts or the wide oceans. So they can relay these messages to satellites, and therefore this can communicate them down to the ground station, and therefore we may achieve Internet of Things with satellite coverage. Of course, we have many problems, because if we have just one satellite, we're going to have a sparse constellation, so we're not going to be able to send these IoT packets all the time. So maybe we can deploy in constellations, but that wouldn't reduce the cost. And the main objective is to keep the low cost and achieve a high connectivity. So the state of the art, here we are combining two different approaches. One is the Internet of Things, which was really hyped before the AI came. So everyone was talking about IoT and the potential things that we could do with these things, therefore Internet of Things. So these are on-ground devices that we can deploy, and we can build ourselves a network and start communicating data with low power, and we can just deploy these networks as we want, depending on the technology we use. For example, LoRa, which is a modulation typically used for Internet of Things, they allow us to deploy our networks in unlicensed bands. So we may just deploy a network and start transmitting, and we don't need to ask anyone for permission because we're working in unlicensed band. Same as you can do a Wi-Fi hotspot. But also we have another alternative, which is NB-IoT, narrowband IoT, which is another modulation used in the context of Internet of Things. This one is regulated, and this one has been is maintained and was developed by 3GPP, which is the association which also builds the 4G, 4G LTE for cellular and 5G. So this one operates in licensed bands. Mainly we have these two alternatives for Internet of Things to achieve low power connectivity. And on the other hand, we have our spacecraft. So satellites that we put in space in different orbits. I mentioned before, our focus is on LEO satellite orbits, but before that we used huge expensive satellite communications in the geosynchronous orbit, so we could have television by satellite. But these were quite expensive. In the recent years, there's been the new paradigm in space activities, space research, mainly in the last 20-25 years. We have achieved to reduce the cost of launching and manufacture and miniaturization so much that now we can afford to have satellites, as we call it, low-cost satellites. Even more with the introduction of the new CubeSat. So the CubeSat is a standardized satellite which falls in the category of nanosatellites. It's basically a cube or a collection of cubes. Each cube is 10 by 10 by 10 centimeters, and it weighs about 1.3 kilograms. And we may stack these cubes, and we can do space research. We can do experiments on orbit, low cost. So what I mean by low cost, I'm talking about $100,000 or $200,000. This is quite cheap considering the traditional cost of launching a big satellite, or just think about the James Webb Telescope, which the project was about $10 billion in total. So this allows us to deploy our own constellation. If we can launch 2 or 3 satellites by small actors, say startups, developing countries, or even universities. Maybe you noticed that in the other room where we had lunch, there were the posters of the Switch-I satellites were launched last year, and I was really happy to collaborate with them, with the SPEL, working on the Switch-I-2 satellite, nanosatellites. So those were 3 nanosatellites composed of 3 cubes, which are carrying experiments, and one of them is especially carrying an Internet of Things payload. And so we can actually do research on this. It's not like out of our mind. So this is how it would look a fully connected space terrestrial integrated network. So I'm going to begin with the right-hand side. You can see a typical terrestrial IoT deployment. We have the nodes, the little blue dots, And these nodes are going to communicate via LP1, so low power wide area networks, to a gateway located in a part of the city or in a suburban scenario. These gateways are connected to internet, so they can relay these messages to the network server and the application server. I'm using LoRa terminology, LoRaWAN terminology specifically, but narrowband IoT works in a kind of similar way. And therefore, the application server may formulate the response or just receive the data that was collected by the nodes, and we have Internet of Things. So what happens when we want to deploy these nodes in an area where we don't have connectivity, ground connectivity for the gateways to be connected to internet? In the middle, we may have, for instance, indirect to satellite IoT, so the gateways will have the capacity to send these packets from the nodes directed to satellites. Here we mention a geosatellite because that's like the easy option, because geosatellites are fixed. It's a fixed point in the space. Geosynchronous orbit is around 36,000 kilometers above the Earth's surface, and the orbital period is the same as the rotational speed of the Earth. Therefore, they're quite useful because if we just point antenna to a fixed point in space, they will always be there. Of course, this is consumes a lot of energy. So we're assuming that we have the capability of relaying data via this link. Our focus is actually on the left side, is the direct to satellite IoT. So now the gateway, the one collecting the packages, the packets from the nodes, the data, is going to be located in a low Earth orbit satellite. So this is much closer to Earth, around 500 kilometers above the Earth's surface. And these nodes will directly communicate with this satellite. The satellite will just continue its orbit until it has a stable ground link to connect the data to the server on ground and therefore reach the internet, and then we can achieve the full connectivity of an IoT network as we want it. So this is our focus, and there are also other possible links that might be of interest. For example, the inter-satellite link, and this is another word, is a really challenging problem. But if we manage to get inter-satellite links, we can increase the coverage of our network on ground if we deploy a massive constellation dedicated for Internet of Things. Or even more, LEO to geosatellite, which is also a topic, recent topic of interest. So I mentioned various type of modulations. So here I want to summarize some of the most important for us, at least. So you can see here the range against the data rate. So the data rate, as you also know, is related to the power. So if you want to transmit even faster data, the range is going to be reduced, but also we're going to spend more power. So we all know, for instance, the Wi-Fi has a really short coverage, but we can achieve high speeds. For example, we have cellular networks, the 4G, which the range is increased. And now even more with the cellular 5G, we can achieve even higher data rates. But what we are investigating actually is the LP1. LP1 is the modulation used for Internet of Things, so we can achieve long range with really low power. But on the other hand, for the satellites, we typically use X-band or X-band, depending on the technology we're using. S-band typically used for LEO satellites. But these are also energy consuming, also because we are assuming that we have a ground station communicating with our LEO satellites. So over the history, these two paradigms, the LEO low-cost nanosatellites and the Internet of Things, have been evolved in a separate way. So the modulations were not thought to be to support satellites in context of Internet of Things, or in the context of LEO satellites, were not thought about connecting devices anywhere on Earth. So our focus is actually the adaptation of existing protocols, so we can achieve a satellite, direct-to-satellite Internet of Things with a really long range and a really low power. So this is more or less the context of the stereo project. Of course, there are many challenges, like this is not an easy problem. We have, for instance, architecture adaptations. We need to revise the radio access, how we are going to use the spectrum, the available spectrum, the payload type. We have the network. The network also poses a problem because the satellite, the orbit of the satellite needs to be calculated. We need to know where we're going to deploy the nodes as the application requires it. Many problems in software and hardware, synchronization and localization. How are the nodes going to know when the satellite is available to transmit? Otherwise, they're just going to transmit and lose the energy they use for transmission because the satellite was not there. So this is also a problem. mobility and routing. So if the package, we managed to send the package from the node to the satellite, and the satellite managed to send the packet down to the ground station, if I need to reach the node again, how am I going to do it? Like which satellite is going to have access to this node at which time or at which moment? And of course, management and operation, this design, the small devices, of course, Internet of Things devices, and most importantly, performance evaluation. What can I really get? How much data can I transmit? How reliable is going to be my network, so I can offer it not just as research interest, but also as a commercial, real commercial alternative. So the stereo project is as I told you, the coordinator is Juan Freire, my advisor, is from Inria León, from the Equipe Agora. But we also collaborate with many actors in France that have experience in Internet of Things, in devices, but also in satellites. We can count, for example, the IRIT in Toulouse. IRIT, I believe, is Institut de Recherche en Informatique de Toulouse. We have the LAS, is a laboratory for CNRS. Le LAS, c'est le laboratoire d'analyse et d'architecture des systèmes du Centre national de recherche scientifique. And we have also the LIC, which is the Laboratoire d'informatique de Grenoble. We also count with the partnership of, we have our industrial partner, Journées, based in Toulouse. They have experience in satellite operation. So we have many different teams across France, mainly Toulouse and Grenoble. So we are working from different contexts. We have different backgrounds, all working in the context of direct-to-satellite IoT. So the general objective will be to leverage and integrate LP1 technologies in the satellite context. We have the specific objectives to tackle this problem, because it's a complex problem: architecture definition, software evaluation, software components design, and also hardware components prototyping. So this is just like a draft slide that we had we devised from the last stereo workshop that we did in October. Something that I forgot to mention, as you can see, there is the ANR logo, the l'Agence nationale de recherche, and this is because the stereo project has been funded by ANR for 4 years, for a period of 4 years, and we just started this year with this project. So we had a workshop a couple of months ago, so we were thinking about what are the objectives of our study. As I mentioned, the direct-to-satellite paradigm is really our focus, because indirect-to-satellite IoT is primarily a technical challenge, with limited research opportunities. License bans is also a problem, as I mentioned before. LP1, we have LoRa, which is unlicensed. If you want, if you have a satellite available, you can just deploy your network and start transmitting data. But sometimes, if you need, if your application requires it, maybe you want to use more data rate or a higher bandwidth, so that will also pose a problem because it's not licensed. So we have regulations, and we need to consider that also in our research. On top of that, we have also the LR FHSS. Before I mentioned to you the LoRa, which is, as I said, a modulation by a company called Semtech. But they release a second new modulation, which is, they say, is specifically designed for this context of direct-to-satellite, but only for uplinks. So there's like still a research topic here that just got open, like how can I make coexist the new modulation with the previous modulation. Of course, also we count with Semtech, this enterprise that manufactures the devices is based in Grenoble. Or the other alternative is NB-IoT. We have the team in Toulouse. Some people work is mainly focused in NB-IoT. So one alternative may be make LoRa more sophisticated, or it's easier than making NB-IoT simpler, because this has a regulation by 3GPP. So lastly, there are some other open problems that fall outside of the scope of our project, but are really interesting and might be really good to integrate them. Like inter-satellite links, this is another really challenging problem, or LEO to GEO links, transparent, regenerative, and hybrid payloads. And so these are just some research topics that we have been working on, because this project started this year, but of course we have been working on this before. Me, my advisor, and others, other people around the globe. So for instance, we have network size estimation. So how can I determine the number of nodes that are competing for the coverage of the satellite? This is a work that I did last year. Headerless decoding in the context of FHSS, which is specific for this type of modulation. Uplink transmission policies, how the nodes are going to send their data to the satellite, like all at the same time. It cannot be possible because we're going to have so many collisions that I'm not going to get anything, so there has to be a policy guiding the medium access control. Constellation design, where can I deploy my satellites, which orbit, which constellation, so I can get the highest coverage in the region that is of interest for my application on ground. Reservation-based protocols, the synchronization of uplink and downlink. This is the problem that I mentioned to you before. Like, if I manage to get an uplink to the server, how am I going to communicate back to this node? We need to do some routing algorithms, planning of when is the next satellite going to pass directly above that node. And downlink strategies, which is just the problem that I was mentioning. To end, for the downlink strategies, I didn't want to put it in a slide because this project is under revision. So we just sent a proposal for équipe associée with the financement Inria. So we plan to study downlink strategies, and the project name is Dorsal IoT. So we'll be focused on efficient downlink strategies, and this will be in collaboration with Chilean partners, Chilean institutions. We have the University of Chile, Universidad Diego Portales, Universidad Técnico, la UTEM, Tecnología Metropolitana, y la Universidad Federico Santa María. They are collaborators that we still have. We collaborate with them in the context of DTS IoT, so really expect to have this équipe associée so we can keep collaborating in France directly from Inria with Chilean partner institutions. So thank you very much, and if you have any questions, I'm really happy to talk about this with you.
Thank you, Diego. So, do you have any question in the audience? We have still a bit of time. Then next is the coffee break, I guess. You want to do an announcement? There is no question.
Yes, I'm the food person. You know, when I take the microphone, is for announcing food. So yes, so now, well, first we thank Diego Maldonado for his presentation. We really, yes, okay. We're really happy that you're here. Thank you very much. Now we invite you to move to a hall to enjoy the coffee break. And in 20-25 minutes we're going to be back, but I'm going to let you know when we are ready. And thank you very, very much, Nicolas, for keeping the time so good. Thank you. Welcome back, everyone. Thank you for your punctuality. We're 10 minutes late, but it's not that bad. I hope you have enjoyed the coffee break. Now we will welcome Cécile Bigorou and Claire Saint-Léguer.
Thank you.
They are from the Direction of International Relations at Inria, and they are going to tell us about the international relations.
And you have a seat. Yes, you have a seat. So thank you for the introduction, and I'm going to be very brief because I will leave the floor in a few seconds to Claire Saint-Léger, who is working with me at Inria headquarters in Paris in the International Relations Department, and she's in charge of developing the collaboration in Americas, plural, and so especially with Chile, and together with Luis Marti, that I guess everybody knows in the room, the scientific director of Inria Chile. They are going to give you some information about the Inria French-Chilean Network for Researchers. Je raisonne ou c'est moi? Okay. Maybe like that. Okay. And then they will give some information about the cooperation programs. So just a reminder that Inria Chile has been existing for a little bit more than 11 years now, but of course the collaboration between Inria and Chilean researchers didn't start 11 years ago, but go more longer in time. But since 2012, there have been more than 650 collaborators in the network, coming from Chilean universities on one hand, and from Inria research centers that are located all over France on the other hand. So as you can see, there have been a very strong dynamics, and on this very nice diagram, you can see that Inria Chile is really at the core of the collaboration that have been developing in the last 10 years. And we wanted now to have some time to focus on the network that is already existing thanks to the participation of all these researchers and how we can make it grow, and also to have a focus on the tools that could help you develop the collaboration within the frame of Inria Chile. So I leave the floor to Claire and Luis. Thank you.
Hello. So yes, the idea behind the network is to make more visible the role of Inria Chile to support and the existing project between Inria teams and Chilean teams, and also to foster new collaboration. And we are co-animating this network. So Luis Marti as scientific director of Inria Chile, and me from Inria headquarters. And the idea is to lead several types of activities. We are identifying new opportunities in France and Chile, the topic of interest common between the two countries, and we can help you to find new partners, researchers, to find also new talents as postdoctoral fellows or PhD. So for example, if we are planning to travel, if you French researchers are planning to travel to Chile, Inria Chile team could help you to meet new people, new researchers, new institutions. And on the other side, if you, as a Chilean researcher, want to visit your collaborator in French, we can also help you to identify new teams, and for you to have additional meeting to make a more fruitful visit to France. And we are sharing all this information about the opportunities, funding programs, and also to make visible the existing project between France and Chile through dedicated communication to individual teams or individual researchers, but also more broadly on Inria Chile website and on Inria Chile social media. So concretely, there are several events organized, these scientific days like today and this week, which aim to be organized on a yearly basis, also summer schools and local workshops. And we have also programs to support your collaboration, and we would like to make today a focus on this program. There are Inria programs to support this collaboration, but also outside Inria, some other programs supported by French and Chilean institutions. So I will present some of this. The successful program of associate team allows to to found 2 teams, one from Inria and one team abroad, in this case Chile. During a period of 3 years, we have an annual call published in June or early July, depending the year, and you can apply. And then, if the project is selecting, you have funding for visits and workshops. In Chile, we have nowadays 8 active projects, and since 2012, already 30 associate teams. We have also yesterday and today some examples of these associate teams. Earlier in the afternoon, I think the team Galinet, we have an associate team with the Universidad de Chile. A second program we would like to focus on is the Inria International Program. There is no current chair from Chile, so this is a call to Chilean researchers, or also to French researcher willing to offer his collaborator to take advantage of this program. It allows the foreign researcher to spend some time in Inria Center. For more advanced researcher, it's about 10 to 12 months over a period of 5 years. And for more junior researcher, it's about 6 to 9 months over a period of 3 years. And the researcher laureate decides of the calendar with the Inria team, which will welcome him or her in the center. And the idea is to spread these months between 1 to 3 or 4 stays to have a continuous collaboration. We also offer postdoc positions. There are reserved slots to support international collaboration between Inria team and partner abroad. And the postdoc doctoral fellows are recruited by one of the Inria centers for a period between 12 up to 24 months, but are encouraged to have visits abroad with a partner and is recruited to work on a project, for example, Franco-Chilean project. And this year we have 2 ongoing postdocs with Chile. And the last Inria program we like to present is the internship program. We have a special partnership with Universidad de Chile, but also with La Católica y La Santa Maria. And each year, 30 students from Chile are going to France to spend 3 months in Inria team. And this program is really successful also because we can see our results continuing collaborations, and sometimes the Chilean student come to do his PhD in France. Sometimes he does his PhD in Chile, but still working with Inria team. So this is a quite successful program. And yes, also outside this Inria program, this is the program Ecos Sud Chile, supported by ANID from Chile part and from France part by the Ministry for Foreign Affairs and the Ministry for Research. And it allows to co-fund bilateral scientific projects. And the last one, with Inria participation and also ANID's participation, as a regional dimension, because this project involves one team from France and at least two teams from 2 different South American countries in 3 thematics: mathematics, digital science, and project related to climate change. And the deadline is in May each year. We had an example presented today. It was a Mistral STICAM Sud project with Inria Chile team, Brazilian partner, Uruguay partner, and also Chilean partners. So if you have some question about this program, do not hesitate to contact Inria Chile team, Luis or me from the International Relations Department, also to find the right tool to support your collaboration. And more generally, if you have some ideas or suggestions to make the network of French and Chilean researchers grow, if you have some needs, special needs or ideas, do not hesitate to contact us. Luis, do you want to add a few words?
No, I think that, well, thanks, Claire. In one hand, the information is really clear. Also, I know there's a lot of information, so do not hesitate to reach out to any of us if you want to know more. I think that the main action is to start with something. So, I don't know, even a program relatively small, like the internship program, we have very positive outcome of thanks to this internship program. There is a collaboration between a Chilean professor and a Chilean researcher, or a group of professors and researchers start, and then this becomes an associated team, and we have like this snowball effect. So I think that the important thing is just to start. Do not hesitate to reach out if you want any information, and count with us to try to start in anything of this. If you don't know whom to talk in Inria, we can try to help you also doing that thing. So I always say that I have two hats. In one hand, the research we do here in Chile, but also have this other hat of articulating and promoting all of these actions. So do not hesitate, okay? There are a lot of nice opportunities. Thanks.
Thank you very much to Claire and Luis. Thank you. Okay. Yes, there are any questions here? Don't be shy. Okay. Well, if you have any question, you know who contact now. Yeah. Thank you. Thank you very much. Thank you to the Direction of International Relations at Inria. Thank you. Now we will resume the scientific session 2.2 with sorry. Okay.
Okay, so this is working. Okay, so we have two additional presentations, and the first one is from Doris Sáenz of Universidad de Chile. Thank you very much, Doris. I have run behind you to organize. Thank you for accepting. So I invite you to present. Thank you very much.
Doris is going to talk about energy and water management system for agro development of indigenous rural communities.
Marimari Compuche, Inche Dorisay, Huechaban Piñé, Quimelfe, Ingeniería Eléctrica, Universidad de Chile. Hola a todos y todas, es un agrado estar acá. Bueno, yo soy académica mapuche del Departamento de Ingeniería Eléctrica. Además, estoy en la subdirección de pueblos indígenas de esta facultad, de la Escuela de Ingeniería. Y bueno, I have to speak in English, sorry. Well, anyway, it's good evening. I am going to present this work that is Energy Water Management System for Agro-Development of Indigenous Rural Communities. This work was made, have been developed with the Mapuche community, José Painicura Huela Ñihuen, in the south of Chile, and also with this University of Chile and University of La Frontera in the south of Chile, and in cooperation with the University of Concepción. Okay, which is the main motivation of this? As me, as Mapuche people, we live now in the city. We don't live in the south, in the land, and the problem is the family disintegration because the migration of the young people. But Mapuche, the meaning of that is the people from the land. Our culture, our life, it lives with our land. We need that to promote our culture. And there is a gap between the Mapuche lifestyle and Chilean society. And this kind of the gap generates a loss of our cultural identity. That really pity. And our culture is trying to respect the environment and its renewable resource. We start to work with the Mapuche community in the south, as explained before. It's the Lasquenche community. The Lasquenche community is the people from the sea. It's very far away, geographic, insulated from the Temuco, that is the main city in the south. And the productive activities, the agriculture from their own consumption, that is typical in the indigenous people. And they collecting also seafood and seaweed. They are connected to their unreliable grid with high frequency of faults. That's it's really bad quality of the electricity. Then we decide to work in the very important problem that is energy, water, food nexus. That is important in all the world. And in our context, we decide to work with the community, rural communities in the south of Chile, and we want to install microgrid that is a small grid that mainly it's based on renewable energy, and the community can use their own resource. That is very aligned with the world vision of the indigenous people. In this case, you can see the microgrid. It's based on photovoltaic panels. They need a storage, probably batteries in this case, because we need something in the low cost. And that kind of microgrid is connected to the main grid. And the idea is how to connect this system. The problem is the pumps. In the south of Chile, there are a lot of pumps installed, but the people cannot use because the cost of the electricity. Okay, they decide at the end to use the pumps using diesel instead of the main grid. Okay, but in the future, I think the rural community needs renewable energy, and they are going to start to use the pumps. Okay, the pumps are very important to the agriculture, to promote the crops and the agriculture in general. The problem is the communities start to use the pumps based on renewable energy without coordination is going to be worse, because the aquifers, the water aquifers, it's going to have problems with less water in general. You know, the scarcity of the water in the world is important, the rural community is more important. Okay, then we are inspiring this kind of system. If you install pumps, for example, to communities or to users, consider the same aquifer, they share the water, they have to be coordinated. Well, as explained before, I'm electrical engineer and work in control area based on computation intelligence. I want to use this kind of strategy, predictive control, for example, to coordinate this kind of pumps in order to don't have problem with the water. That's the main problem. And that kind of pumps, the idea is to install a microgrid based on renewable energies. Okay, but there are a lot of challenges instead of problems, really, because you need to define the irrigation for different type of crops. It's also interesting problem. How to coordinate this? You need to predict. You need to predict in the future of the climate condition, as for example precipitation, that are very important for the crops, and also as well if you have solar panels, the solar irradiation and other climate conditions. Okay. How to define this? We define energy water management system. In this case, we separate in two problem, optimization problem. One is in the medium term, that means it's around 30 minutes sample. And the other short term, you have to operate the microgrid energy. How to operate the microgrid if we are going to purge the energy, sell the energy to main grid, or we are produce our energy from the photovoltaic panels, for example. Sorry. Then the first problem, the water management system deliver the daily water requirement for each crop. That's it. The different crops have different necessity of water. Okay, the energy management system deliver the control action for if we want to purge, sell energy, chart the energy storage system, and the operation of the pumps. That is the relation between water and energy. Okay, how to do that? You need here is René that is expert in this in climate condition. We need the meteorological data, but not just at the instant. We need to predict 1 day ahead, 2 days ahead, how to do it. But if you want to take better decision for the crops, you need to predict 1 month ahead how it's going to be the climate condition. Okay, that says this water management system is more focused in the crops, and they need a prediction for 1 month. Okay, and the energy management system is for the operation the microgrid during the day that needs 2 days ahead of prediction. Okay, we define this using model predictive control, that is MPC. We minimize the cost of the energy transaction between the main grid and minimize the water that was not supplied for the farmers, as well as the lost water due to the excess of the irrigation. These are the first equation. And the second is the energy balance that you require. Okay. For the water management system, we need to maximize the relative yields of the crop. Okay, that is the more important things. And as I explained before, you need to predict the climate condition 1 month ahead. That is challenging. Okay. Well, we have some results of this. We have some scenarios of the estimation of the aquifer research. Okay. First, when we consider 15% and 30% of the precipitation, that is a bad scenario. And also when you can measure just the rainfall and you consider this in the future. Okay, these are the scenarios in the different color and the rainfall in the blue. Okay, this is a result of the complete system, energy water management system based on predictive control strategy. We present the crop yields in the gray color. The irrigation we present in the red color, yes, and rainfall in the blue color in the last graphic, and estimate research for the scenario of 30% decrease in rainfall. You can see different results for potato, pea, and tomato, because you have to consider the characteristics of the crops. Okay. I am going to present some results in terms of the cost and profit on the water. For different scenarios, you have normal rainfall decreasing 15% and 30% on the rainfall. The cost is meaning if you need to purge the energy from the main grid. Profit if you can sell the crops at the end. And the water consumption that is extracted from the aquifer. Okay, we observe lower contribution rainfall in the natural irrigation of the crops, less water ability to extract from the water from the aquifer. The main things, as there is a reduced rainfall, the system tends to require more water from the walls. However, as there is less recharge of the aquifer, this extraction is limited. That's the point. When you use a predictive control, you can include constraints. That is the main advantage of this control method. That is very interesting. Okay, some remarks. The results show not all crops met the minimum requirement. You can see at the end of the graph here the crop yields. The idea is to maintain in the optimum. The optimum is 1 for the yields of each crop, and you can observe decrease until some months. Okay, and this kind of strategy is very flexibly to include different kind of crops and aquifers, and the idea is to try to obtain the best economic return from the crop yields according to the available, according to the water and energy. Okay. Now we continue this work with Linda Daniele from the Department of Geology, and we complete this model in terms of to model more the hydrogeological system, how to model the aquifers. Okay, we include more real data, more information of that to complete this model, and the main contribution, we have a better estimation of the groundwater chart. That is very important. That have to complete this balance. The precipitation, my irrigation have to be equal to the evaporation, to the runoff, surface runoff, the pump, the groundwater extraction by the pump, plus of course the groundwater recharge. Okay, that is the main point that we can complete our model. We use in this case some computation intelligence model, in this case fuzzy model, to estimate the precipitation, to estimate some variables that contribute to estimate at the end the recharge of the aquifer. Okay, and then we have the same system, okay, that a water management system plus the energy management system, but in this case we include a more detailed model of the recharge, precipitation, solar radiation, and other variables. How to model that? That kind of model are very stochastic, really, and you need some tool to estimate not just the expected value. You need the band or the prediction interval that contain the data in the future with 95%, for example. How to do that? We use in this case a fuzzy prediction intervals. The idea you can see in the circles the real data. You can see in the red color the expected value calculated by the Takahashi model, and the band is in the green color. The idea it's complex. You have to predict in the future the band that contain the data with 95% of confidence level. Really, it's a level of coverage. Okay, how to do that? You can estimate by fuzzy Takahashi model. That is a multiple model that are combined with the fuzzy logic prediction interval, where we have an equation of function that calculates the upper level, the lower level. Okay. Why is important this? For example, if you predict the wind speed for the wind turbine, you need to operate the system in the worst case. Which is the worst case in the future? The lower band of this. Imagine this is a wind speed. You have to operate the wind turbine. It has less risk if you operate in the worst case in the future. 2 days ahead, Canela is going to be in the worst case of the wind speed. Then we are going to have this energy able. Okay. Okay, it's high cost, but you have less risk to provide the energy to the consumers. Okay, that's it. Very important with the renewable energy. That kind of modulation in the future to take a better decision for the operation. Okay, this is an example of irradiation. Okay, you have the band in the gray color. In the blue color, you have the real data, the expected value in the red color, and some results in terms the error the model for the different prediction horizon, 10 minutes ahead, 1 day ahead, and 2 days ahead. And you have this is a coverage level of the prediction interval. We want to fix in the 90%. And we attain 91%. If you do 2 days ahead, it's very good. And but the band have to be as narrow as possible, because of course in the future you can have a 100% if you fix a very big band of the prediction interval. In this case, you fix as minimum as possible that band. This is in percentage. That is okay in the future. And well, we have some result of this energy water management system. For example, if you define the predictive control, we have a simulator. We obtain some result if we use real data in the future. That is the base case, just to compare by simulation. Then you can compare with expected value, and then you can compare with the worst case. Okay, and then between the worst case, you can set different case with 50% of the precipitation, 75% precipitation, 25% of precipitation. Okay, and here the same we have, but in different colors, different students, relative yields of crops in colors, different colors. This is the optimum case, because you use the real data in the future. But this simulation, you can do it in the real application. It's not possible. And you obtain the optimum. All the crops are in the optimum, in one of the yields of the performance. Then you have if you use the expected value, you obtain worse results, and in different case also as well. But this case is interesting, because with the rules, that means use worst case, you can obtain the optimum one, because you use the worst case of the prediction intervals for all the climatic conditions, and then you obtain the optimum in the crops. Okay, that is very interesting. Okay, some remarks in this. Well, it's interesting because with the formulation management system permits a better resource management compared to consider each system separately. The idea is to connect the energy and water problem in the one system. Using the prediction intervals, that means robust predictive control, we permit to maximize the crop yield and as well minimize the water used in the under the different kind of disturbance. Okay, and finally, we intend to apply this in a real case at a pilot scale, a prototype. I would like to share. We consider how to test this in the rural community. We decide to start to work with the greenhouse. In the greenhouse, you have the same problem. You have the aquifer, you have the pumps, usually tanks also as well to storage the water, and the irrigation for the greenhouse and different crops. Okay, and the idea is to install pumps based on microgrids or small photovoltaic panels. Okay. We decide to work with the young people, with the children in the schools. We're talking about 12 years old around, because there are a lot of challenges in the rural areas. There are limited technology access in the rural areas. There are economic constraints, isolation, and we see that this early involvement of the user, in this case student at the school, emphasizing cultural context. The idea is to develop with them using their world vision as well. And the integration of technology, integration at all levels is really important. We integrate this with the development of Internet of Things, because in the rural area also there are a lot of challenges with the communications. Okay? You can define also intranet, instead of internet. And the idea is to co-design with the student and using their local context. We think this is the case for the successful implementations, not really. How to do that? We define with that participatory workshop using the ethnographic method. We were the interdisciplinary team. The idea is to build the greenhouse with the students that was in 2 schools. How to do that? We define some workshops in different topics, for example, water and energy resource, renewable energy, Internet of Things sensors. And we implement a greenhouse with the sensors based on small nodes that are connected to the small photovoltaic panels and pumps, all the technology I shown before. And the idea is to measurement the temperature, the humidity, and all the variable climate condition, and the student can build with our team to learn all the things and build this implementation. You know, the predictive control is a strategy that's based on optimization, but there are other kind of control systems that are easily for the student to understand that. For example, FAXI expert system that you can develop with the student at the school. And finally, well, for us it's very important that the student involvement. We define that the students are very critical in the Internet of Things, sensor, water efficiency, and the education of this topic have to be when they are very young. And also, we seem to involve also the teacher, motivate the student, and also can change the curriculum at the school. And for us, it was a learning experience. We try to develop with our students at the university level and our professor a methodology how to implement this with the community. In Chile, it's very complex to install technology in the community because usually the government install, but the project cannot continue during a long time because nobody is in charge of the system, and at the end the investment is lost at the end. And we are working in low-cost approach of course of this kind of implementation. Thank you very much. Turn to Mike.
Well, I couldn't introduce Doris before because I was not ready. Hello? Yes. So, but just want to be formal here. Doris has a PhD from the Catholic University of Chile, and she's a full professor here in the Universidad de Chile in the Department of Electrical Engineering, and she is a sub-director of indigenous people of the Faculty of Mathematics and Physical Sciences here. No? Hello? Hello? I have to eat the microphone. Yeah, so just wanted to give the proper introduction for Doris because I was not ready before. Doris has a PhD from Catholic University of Chile. Now I learn by memory. And she works as a full professor here at the Faculty of Engineering, of Department of Electrical Engineering here in the University of Chile, and leads the subdirectorate for indigenous people of the Faculty of Mathematical and Physical Sciences. Her work topics you already saw because I was late for the introduction, so it's mainly fuzzy related topics. And well, now we are ready for questions. Please. I go. Wait a second.
Hello? Yeah? Yeah, okay. So as you know, we had 2 big rains this year in August and in a little bit further. I don't know which month. You know, it was a disaster. How do you think that will affect the future model? Well,
Tienes que ponerte el micrófono así.
más fuerte.
Ahí.
Okay, yell. See? Well, yeah, we had two big rains this year, August, and I think a little bit farther, a couple of months. So it was huge. How do you think that will affect the model for the couple of years coming? No sé si me explico.
Haz la pregunta en español.
Ya.
Es que se escucha muy mal.
Es que hubo como los dos aluviones que hubo este año, fueron gigantes, dejaron la embarrada, por decir un poco más coloquial. ¿Cómo eso afectará el modelo en los siguientes años? Sobre todo porque esperamos más aluviones así, imagino.
That is important. The problem is how this model is going to be affected with the crisis of the water in the future, the climate change in the future. Yes, that is your problem. Okay, of course. Our idea is to work with René, the other expert. We work now with Linda Daniele, that is from the Department of Geology, and we start with Javier, that is a new PhD student, working to complete the model in the future. But our idea is to complete that kind of model with the experts, because we are using Tagaji Sugeno as a black box, yes. But of course, it's going to be better if you use all the knowledge of the expert, yes. But also, we start to work with evolving systems that are very important. Evolving systems are a methodology that permit to adapt the model if you had a abrupt change in the parameters or in the structure. That is a nice strategy. Yes.
Any other question? I have no, please. I have a small one because I just didn't understood. Do you simulate the crop production, or you have like how do you can know what is going to be the outcome of the crop based on the I didn't understood from the presentation, so if you can.
The truth it's very simplified model of the crops. Really, we take some parameter of the agronomy that define different crops in terms of yield, the optimum yield in terms of the date or the frequency of the irrigation. But we want to complete with the agronomy, but we don't have collaboration, and no, we can have from France.
Thanks. Actually, I see a project here because in the morning, Philippe presented these approaches that apply reinforcement learning for doing like an automatic agronomer, no? Based on, so it's a clear overlap. And we connect this with satellite LoRa-1 connections and everything is set up.
Yes, we start to solve this with the reinforcing learning also as well with other students that he couldn't combat. It's interesting because we have to adapt this system because there are a lot of stochasticity and abrupt change, etc. Yeah. Okay.
Thank you very much. Any? René? So now we have René Garot. Did I pronounce it correctly? Well, thanks. He's a full professor, also here at the University of Chile at the Department of Geophysics. I'm director of the FONDAP Center of Excellence for Climate and Resilience Research. He has been director of the Department of Geophysics of the University of Chile and president of the Higher Council of Sciences for FONDESIT. He was an invited researcher at Yale University and maintains an active participation in national and international initiatives. So thank you very much, René, and thank you again. I apologize to everybody because I've been bothering people for sending the slides. Thank you very much.
For the invitation. Can you hear me? I know that no. There is a Here? Oh, there you go. Can you hear me? Yes. No, I thank you for the invitation. Actually, I was invited by Jaime San Martin, who is not present now. And Jaime contacted me like 2 or 3 weeks ago, said, can you participate on that? And I said, what do you want me to talk about? And he said, speak about anything. And I will speak about anything or everything. Well, actually, I work at this Center for Climate and Resilience Research, which is a consortium of about 60 researchers here in Chile, with people from University of Chile, Universidad de Concepción, Universidad Austral. And Jaime is there. Good. I was telling that you invite me and said, talk about everything, whatever you want. So basically, in my center, we work with climate change and resilience to climate change, and this is generally bad for you, right? I mean, the climate change, not us, because it involves things like extreme events, hyper droughts, El Niño Godzilla, and most of my talks are about these themes. But since Jaime said me, you have the freedom of pick any topic, I didn't choose any of these very pressing issues, and I rather will tell you a story about a total solar eclipse in the Antarctic in the middle of the night. This was an interesting story. And I know that there are probably not many meteorologists or astronomers here. So rather than focusing on the science, which is interesting, I will focus in this story behind this research. That's involved collaboration, with a few French people, but also people from the United States and Chile. This is the list of my co-author. This was recently published in a paper that's appeared now in the Bulletin of the American Meteorological Society. This eclipse took place in December 2 years ago, almost 2 years ago. Actually, exactly two years ago, right? Today is 4 or 5? Well, more or less 2 years ago. Yeah, for meteorologists, but for astronomers, this is really important today, and they can precisely know when an eclipse will take place. And I was surprised that, in fact, the eclipses are fairly frequent. You have an eclipse, a total solar eclipse every 2 years, more or less, on Earth. But if you are in a fixed point, you have to wait like 4 centuries to have a total solar eclipse. So if somebody told you there is an eclipse coming to you, you want to be there, right? And of course, there's a few studies on eclipses in Antarctica. Astronomers are quite interested in eclipses because even though they're ancient phenomena or known for so long time, they are kind of a natural experiment, and they can still learn something about the sun. So this guy, Patricio Rojo, which is an astronomer working here at the Department of Astronomy of this faculty, told me, well, there is an eclipse, let's do something. And we put a project. First of all, well, only 2 of us could go, and I was the 3rd. So I didn't have any expectation of going to Antarctica. But the second person suddenly got sick. Don't ask me why. So I changed from 3rd to 2nd, and I had the opportunity to go to Antarctica. And it was a fascinating, I never done much research on Antarctica, but I had the opportunity to go there. And I went there. Basically, we installed a station, and there is a lot of possibilities. There is, well, Antarctica is so remote, so it makes a lot of sense to me to try to get this information from weather station, from satellites, especially from low orbit satellites. But still, anyway, we install our station in a place called Union Glacier. By the way, let me go one back. Union Glacier is here, not in the South Pole, but at 80 degrees south, so south enough. And another interesting thing is that the eclipse in local, well, we think that Antarctica is Chile, right? This is what Chileans think about Antarctica. So we use the local time of Santiago, and the eclipse was around 4 a.m. So when at home I said, I'm going to Antarctica to see a solar eclipse at 4 a.m., obviously nobody believed me. But believe me, the eclipse took place, and it was total, because you are under the solar circle, the south polar circle, so there is 24 hours of daylight during summer. And we were right there in this, can you see? Oh yeah, we were there. So we went 2 weeks ago, or 2 weeks before the eclipse, we installed the station. There is some stations in Antarctica, but we try to get something called micrometeorology observations, solar radiation, infrared radiation coming from the Earth, infrared radiation coming from above, etc. We also had this drone, and we put these meteorological zones so we can make profiles of the temperatures and learn a lot of what happened in Antarctica. It was 24 hours of daylight. It was incredible. I wake up like at 3 a.m. I open my eyes. It was like 3 p.m. So incredible. And we learn a lot. Obviously, there is people that are expert in this Antarctica meteorology, but I learned quite a lot. The days before, as I said, we arrived 2 weeks before the eclipse. So I had to do something. I learned Antarctic meteorology. And everybody asked me, how big will be the eclipse in terms of the drop in temperature? It will drop, because we were roughly at minus 20 degrees centigrade. So the people ask, we will go to 80 degrees or 50 degrees, or what will be the change that you expect in temperature? One way, and again, I don't want to go in these details, but basically you can equate the cooling that will take place in the surface. These are profiles of temperatures with height, and regardless of the initial conditions, basically the eclipse will be around 2 minutes in which the solar radiation, of course, will disappear, and this reduction, this deficit in solar radiation, more or less, it's proportional to the change in temperature. And because I installed this station, I know more or less how much energy we will lose in these 2 minutes, because we have many days without clouds before the eclipse. I had quite a good idea of what will be the net solar radiation deficit. So I could estimate the temperature change. And of course, I organized a contest. I asked all the members of the base, how will be the maximum temperature? And I knew the answer. Of course, we bet for, I don't know, a bottle of whiskey or whatever. And well, yeah. So my bet was around that the temperature will be around 3 degrees centigrade. And here there is, well, this was spectacular. Remember, we were 2 weeks before the eclipse, and every day was sunlight, the 24 hours. So this was a very welcome night. Only last 2 minutes, but we really enjoyed this 2-minute night this day in December 14. And the temperature, of course, the solar radiation went down, and the temperature, roughly, it changed 4 degrees. So I have my bottle of whiskey with me. All the guys said it will go 10 degrees below or 50 degrees below. Well, this is the good idea of having a small model and do some guesstimate based on this model. Of course, with just one point, you can do much. So I start contacting people. There is many institutions that do research in Antarctica. I had the lack of contacting 2 people at Wisconsin University, and they have, well, not all these stations are operated by them, but they collect data. So I asked them, and the guys respond like in 24 hours. Yeah, we will send you the data, and in fact, they send the data, and it was very interesting. When you start looking, these are different temperature changes, and this is the eclipse. The yellow is the change in solar radiation, and the blue is the change in temperature. So in some stations, like here in Teresa, the temperature drop was very evident. But in others was not that evident, so we did a little bit of a, not very simple mathematics. We basically removed the part that was related to the eclipse and fit a curve and try to estimate the temperature drop. What I want to say that's even having the observation, it's not so easy to estimate the temperature drop. But eventually we did these estimates, and here came something interesting. Again, we were here in Union Glacier. These are the lines of obscurity. So in this band, the obscurity was 100%, and we were right there when the sun was completely dark during these 2 minutes. And the colors indicate the temperature drop. As I said, in Union Glacier, the temperature went down about 3 degrees. But as you can see, well, there's some stations that were within they call the path of totality. And they didn't experience any change. By the contrary, some stations here close to the dome of Antarctica, they experienced changes of 5 or even 6 degrees during this 2-minute period, even though the obscurity was not 100%, was 80%, which is just a partial eclipse. So there was this little doubt why there is, why there is this change. In fact, I ask this to my students now in meteorology class. Where do you expect the maximum cooling? And most of them will say, we expect the maximum cooling here following the track of totality. But the maximum cooling was not there. Why? So we took the same model that we had before, the change in radiation to roughly equal to the temperature change. The problem is that in other places, we didn't have these detailed observations to tell us how was the change in solar radiation. But if there is a clear skies, you can make a good estimate of how much radiation you are receiving at this time if you know exactly the position and what they call the local circumstances of the eclipse. So we take this estimate, and this part of the equation, the change in solar radiation, was estimated assuming clear skies. And here again, for instance, how much was the duration of the eclipse in other places? Well, we asked this French colleague, Xavier Jouvier, and he's an astronomer, and he has exact locations of the eclipse, not only this one, but for the eclipses in the past and in the future. So he gave us all the information that we needed to train or to run this model, and doing this, we get something like this. So this is a very simple model, a very simple estimation of the cooling, and in fact, it predicts that the maximum cooling will take place not in the path of totality, but here in East Antarctica. And this is because even though here the eclipse was not total, the sun was slightly higher over the horizon. So they got more radiation, and maybe the radiation went to half of what was without the eclipse. But there is a lot of, this was a big loss of radiation. So that produced a big drop in temperature. While here, even though that the solar radiation went to 100, or went from 200 to 0, 100% obscurity, the eclipse was not so dramatic because the loss of energy was not as strong as here in East Antarctica. Now, it looked okay when you compare with the observations broadly, but when you make a scatter plot between what is predicted by this model and what was observed, it's not that good. And of course, a primary cause of this disagreement is clouds. If there is clouds, all the calculation was assuming clear skies. But if there is cloud, the eclipse has no impact whatsoever. Now, getting the clouds over Antarctica is not easy, and Roberto Rondanelli, a colleague also in the geophysics department, helped us in doing these estimations. But even accounting for clouds, we didn't do well with this simple model. So now is when you want a real model. And a real model is a model that takes all the equations of the atmosphere, momentum, continuity of mass, energy, etc. These are so-called numerical model for basically weather prediction. And something that is incredible is that people already have developed an eclipse module. You can turn off the sun in the eclipse in the model. So in this context of this model, you can have a factual simulation with the eclipse and a counterfactual simulation without the eclipse. And in this framework, the change of any parameter is very easy because you just make the difference between the simulation with the eclipse and the simulation without the eclipse. In particular, the temperature is what is there. But we didn't have this module. So what you do in these cases? Well, you look in the literature and say, oh, these guys have something. They have the module. So we wrote them, and people are very enthusiastic with this and said, yeah, of course, we can help you to run, and they provide us the module for, the model is called WRF, Weather and Research Forecasting. It's run actually in the national NHLP, well, this big computer that you have. So we were grateful, and it is in the acknowledgement section that we ran the model there. We did a lot of simulations. I will skip the details. And this is what you get. Of course, the model, these two simulations are identical before the eclipse, but then one simulation goes to 0 in terms of radiation, and the other doesn't feel the effect of the eclipse. And here are the temperatures, again, identical before, but then you have this temperature drop. And again, this temperature drop is about 4 degrees. We had a number of simulations, and all of them agree in more or less 3 or 4 degrees. And now this is what is predicted by the model, the maximum cooling. And here I superimpose the observations. And again, this is the scatter plot. Sorry, that's the letters are very small here. But this is the WRF simulation. This is the observations, and it's reasonable. It's a good agreement. something is going on here. Oh, okay. And Union Glacier, actually, in this place, the simulations was very good. So we were pretty happy with this simulation. You can see that there is a lot of details in the temperature change, and these are probably the effect of clouds. By the way, just I don't know if this will work. It should work, but it doesn't work. It's an animation. If somebody is interested, because this is the maps before are the maximum temperature, but you can see how the eclipse and the solar radiation progress from east to west, and also how the temperature lag with a few minutes, and you have all these kind of effects. As I said, the temperature drop is mostly dictated by the change in actual solar radiation, taking in account of clouds. For instance, here, I don't know, I don't remember what are the color code here, but this is the temperature. Here, for some reason, they change in, probably there was a cloud, so there was no much change in solar radiation, and there is no much change in temperature. Luckily, here in Union Glacier, we were under clear skies, so there was a decent change in solar radiation and a lot of temperature drop. So many fine details are reproduced by this solar radiation deficit, including the clouds effects. But when you look in a broader context, there was one sector that was interesting, because in this East, precisely here in East Antarctica, there was a significant loss of solar radiation of about 200 or even 250 watt per meter square in this area. This is how much it was lost because of the eclipse. But the solar eclipse it did a lot here, but not much here. So the rest of the research, and again, I don't want to go to the details, was trying to explain why, even though this is actually, can be seen here, each point is a pixel in this domain. This is the axis of the solar radiation, including the clouds effects, and this is the maximum temperature. Actually, the yellow points are those locations without cloud effects, and you can see this very good match. The most you lost of radiation, the most is the cooling. But there is stations or places around Antarctica where there was a lot of losing in solar radiation and nothing happened in terms of temperature. And this was not a cloud effect, it was something else. So we have been diagnosing what happened there, and probably this is this sector precisely of East Antarctica. And even though here it was clear skies, the winds were very strong. So another effect that's also mediate the effect of the temperature is not only a radiative effect, also you have to consider the clouds, and in top of that you have to consider this dynamical effect. The stronger the winds, the less is the possibility of develop a cooling in the surface because of the eclipse. So, well, these are the scientific conclusions, but again, I have this as a very good example of a scientific collaboration between teams in Chile, in France, in United States, etc. When you present people an interesting problem, people will get interested and they will collaborate. So I think I talked too much. Thank you again for your patience. And I just finished with this very nice, this was my tent. I lived like 3 weeks in this tent with this jacket. Thank you so much.
Thank you very much. So I cannot avoid the joke. What a cool presentation.
Oh, thank you, thank you.
So any questions, please? That counts as a question. Wait a second.
Lucky with the... Yeah, actually this was the day before the eclipse, and these are cirrus, there's this very thin and high clouds. But Patricio, the astronomer, was like in crisis, because we had really clear skies, and for my observation, maybe it wasn't that important, but for his observations, having real clear sky was so important. But we know, interesting, Antarctica, you think, well, the Antarctic periphery is quite cloudy and windy and stormy, but the interior, and we were not quite in the plateau, but we were in the interior of Antarctica, and it's generally a very dry place, and sunny in summer, at least.
Thank you very much. I think we found.
Then we can talk about climate change and the things that are really important, but I couldn't avoid doing this.
No,
Thank
I
you.
think that we found the location for the next Journées Scientifiques. It's a perfect
Absolutely.
venue.
Thank
Thank
you
you
so
very
much.
much. And I think I yield the floor. Thank you very much.
Thank you very much, Luis. Well, thank you to Rene. We didn't ask if anyone has a question. Okay, so I'm sorry. So now we are going to have the roundtable enabling factors for artificial intelligence in Chile, opportunities for EU-LAC, Europe and Latin America cooperation. So I invite to the stage to Jaime Ortega from Copernicus, Chile, de la Universidad de Chile, Jaime San Martín, del Center for Mathematical Models, CMM, Universidad de Chile, Felipe Tovar, de Inria, and also for the Center de Matemática. And well, our director Nayat Sanchez P, and also Rodrigo Duran. Rodrigo Duran. Thank you. ¿Aló? ¿Cómo estás? Hello. Well, good afternoon, everyone. It has been a long day, long second day. Thank you so much for being here. It's my pleasure to moderate this panel, enabling factors in AI, for AI in Chile, opportunities for cooperation between European Union and Latin America and the Caribbean. So in India, as you know, we have the mission of connecting excellence, research, and also transfer innovation, but also with public policies. And this is why we have been collaborating also with Chile, with the national plan and the national strategy also for AI in different ways. And this is why it was almost mandatory for us to include a slot during the Journées Scientifiques Inria Chile, in the program, to open discuss what can we do to collaborate and better collaborate between the two regions, especially between two regions, Europe and Latin America, France and Chile. How can we do it better, and how we can act collaboratively to unleash the position of Chile as a leader in Latin America. So to discuss here, we have the honor to count with the presence of distinguished panelists. I'm very happy to share the stage with these colleagues that I appreciate so much. And well, Jaime San Martin, that I think it was not properly presented, not only because from Universidad de Chile, CMM, the scientific director of the NLHPC, and who was recently awarded the Chilean National Prize for Exact Sciences by the Ministry of Education. So thank you, Jaime, for being here. Jaime Ortega, which is a professor of the Universidad de Chile, also researcher from CMM, and also the lead of the Copernicus Regional Center for Earth Observation. Felipe Tovar, who is the director of the Initiative for Data and Artificial Intelligence from Universidad de Chile and the Faculty of Physical and Mathematical Sciences, and also a researcher of CMM. Thank you, and Rodrigo Duran, to detonate. Yeah, yeah, but something in between also. Rodrigo Duran, which is the currently is the manager of the National Center for Artificial Intelligence in Chile. So thank you, the four of you. Thank you so much for accepting to take part of this discussion. And I want to dive directly to the point. We have 15 minutes to discuss a little bit about AI, about the challenges, about enabling factors, and what can we do to promote a collaboration to unleash this.
So as you know, this has been a discussion. I mean, in several ways and in several contexts, that the development of AI, in particular in Latin America, is uneven. I mean, while it's true, there's a lot of proliferation and application. I mean, the region is quite far from being able to fully exploit the potential of AI, and that has to do mainly with enabling factors of AI, in part have to do with the infrastructure capabilities, right? So, and computing infrastructure is key on this. So Jaime, I will jump directly into you. I mean, in France, you know, we have a national strategy for AI and infrastructure. I mean, it's a key thing, and since we launched the National Plan for AI in 2018, we have invested a lot in computing infrastructure. I mean, in 2019, we launched this supercomputer, the Joliot-Curie, in Bruyères-les-Chantelles, with a capacity of 20 petaflops. Also in 2020, we launched the inaugurated in Saclay the supercomputer Journées, with a capacity of 36 petaflops and almost 37. And more recently, this year, we just inaugurated in Montpellier this supercomputer Ad Astra with 74 petaflops, right? So what is being done or could be done in Chile around this, and what are the opportunities that you see for a collaboration between Europe and Latin America and the Caribbean?
Okay, a tough question. Can we turn off the air conditioning? People cannot hear correctly, I guess.
Can you turn off the...
Okay, I will try to speak louder. Well, just the context. I'll give you the context. Chile has some advantages in the region for developing artificial intelligence and modeling and data analysis and so on. But not many. I will try to explain why, and then I will go to your question, okay? The main bottleneck is people. We don't have enough human resources. We don't have enough from technicians up to PhDs. So I will give you a number. In the region, Chile in particular, we have 1 researcher per 1,000 inhabitants. In France, probably you have 1 per 100, so 10 times more. In Spain, you have also 10 times more. So the average in the developed countries is like 1 per 100, even 2 per 100. So there is a gap. This is the most important gap. I think we can spend money in infrastructure. That's not a big deal, I hope. But we don't have people trained to do that. So we are stuck with that. In terms of, so we have this 1 to 10 difference. And as you say, France has, I don't know, in these 3 supercomputer centers, around 120 petabytes of computer capacity for the whole research and development. Spain is just buying a new computer installed in Barcelona with 200 petabytes of that order. And so a French researcher will have 30, 40 times more capacity per person than a Chilean one. So it's impossible to compete in that. We have to be 40 times smarter, I guess, which is not,
but my question
not
is
the case.
It's not how to compete, it's how to collaborate.
Yeah. But in order to collaborate, you have to be standing this more or less the same ground. So it's impossible to collaborate when you have this big difference. um, we have just finished, to answer your question, we have just finished a big project with the European community, led by the Barcelona Supercomputer Center, where Inria was the big player on that. And we were invited to be the Chilean counterpart. The main objective was to establish network and to collaborate on that. And for us was very important because that opened a way for the whole country. Our Center for High Performance Computing, which is something that belongs to everybody in Chile. It's installed at the University of Chile, but it belongs to everybody. Everybody can use it in the same grounds. Okay, so that's the main idea, actually. So we have everybody in Chile had access to that network, and we are trying to come out with a continuation of that project, where Inria, Barcelona, a big center in Germany, the big center in Italy are collaborating. So, and in South America it's Brazil and Argentina and Mexico, no? Yeah. So we have good networks, and this is the only way, I guess, for the moment, to develop artificial intelligence in Chile. We have excellent groups in Chile. We have a very good science in Chile, but it's small. I have a table that I cannot project, but I have it here. I can give you some numbers, okay? This is a table that is produced by the Easy Web of Science, and it's an accumulation of 10 years of production, scientific production by country. Well, the big player is China now. It's a little higher than United States in terms of volume. France is in 8th place. It's a wonderful place to be. Spain, I like to mention Spain because in Chile we think Spain is part of Latin America, so it's undeveloped. But Spain is in the 11th place. Spain is producing now something of order 800,000 documents, articles in 10 years. France is producing 850,000, so almost the same. But Spain has a population of 45 million and France 68. It has a GDP of 3 trillion, France, and Spain has 1.5. So Spain is getting a big player after 40 years of darkness, no? Chile is located in the 43rd place. It has an income of 300 billion, so it's 1/10 of France. And we spend 0.4%. This is unbelievable of our GDP in science, while France is 2%. So there isn't possible to compare. But if you divide it by the GDP, we are not so bad. We produce 100,000 documents. So 1/8 of France or Spain with 1/10 of the money. Okay? So the worst numbers for Chile are when you divide it by population. We are an equivalent of an European country of 4 million people. So we don't give opportunities to 3/4 of our population. This is the main bottleneck to get developed.
You think it's different in Chile than in the rest of Latin America?
No, it's more or less the same.
So I will go then to Rodrigo with respect to that, but before that, I will jump to Jaime Ortega, the other Jaime, the other Jaime, and talking about another enabling factor of AI, which is data, right? And I mean, it's a key component for the development of AI and modern AI, and Jaime, for the ones who don't know, I mean, the European Union is part of the Global Gateway Strategy, is funding some initiative, and well, you're leading one of them, which is the Copernicus Regional Center for Earth Observation. So with respect to data, how you see, I mean, Chile in this landscape? How do you see regarding access, data repositories, I mean, the vision and how we share all of that and for what? So how you see Chile in this respect, and how is the European Union and this funding especially is helping to bridge this gap?
Okay, for the invitation. Can you hear me or not? Yes. I have been a couple of days ago in Cartagena, in Colombia, in a meeting of the digital agenda of European Union and Latin America. For one side, it's very surprising that Chile is very well considered for the European community, in particular for the European Commission. I think that there's a lot of initiatives which are looking at Chile as a very important point. I think that as our colleague Jaime Campos say, Chile is a very natural laboratory for science. In geophysics, in geology, Chile, we have almost every disaster, for one side. we have a lot of different kinds of activities. We have the Antarctic, as say René, but we have the desert, we have glacier. 80% of the glaciers of South America are in Chile. And for the reason, Chile is a very important laboratory. I think we need to improve the way to share information. I think that this is a big question, and it's a big problem now. Okay, there are a lot of initiatives. Okay, there is an important initiative, the GGIM of the United Nations, which is a community of the national institution which must share and study what happened with the geospatial information, the IDES. Okay, the president of this institution is a Chilean, Sofia Nilo. Okay, for that reason, we have a huge opportunity to begin to share and coordinate what happened with the data. I think that there are initiatives, there are a lot of centers. There are CR2, there is CIGIDEN, there is CITREND, and several one. And one thing I think is very important to advance in a cooperative way to share the information. There's a lot of information generated by public funds, by different kind of projects, and we need to advance into things. Firstly, to have common protocols. Without protocols, the information cannot be shared. We need to have the way to register the metadata in the way to have the information. And the second one is to coordinate how we can share this information, because without information, you cannot do AI. it's basic. I'm mainly thinking also in geospatial information. From the other side, the European community and the European Commission in particular is very interested in to put Chile in a very important point talking about data. The creation of the regional center of Copernicus here in Chile, and in particular in this faculty, they give us a task, they give us a job in the way how we can coordinate the information of all Latin America and share the information in order to construct new tools. For instance, how we can construct a land use and landscape for land cover for Latin America, for instance. We need to share information in order to validate. How we can generate the information for the surveillance of the seas and our coast. We need information. And for that reason, I think we have a huge opportunity. We are in a very good moment. I think we have the support of the European Union. And we need to advance. We need to talk between us.
Can you tell us a little bit more about the mission of the regional center and how can we build up things? I mean, on top of that, what is the mission of this regional center and how can that help, for example, to build proper
Yes.
applications that
We have the mission to generate in some way maybe a federation of data or something like that in order to share information, in particular geospatial information, of all Latin American and Caribbean. Okay, this is our idea. We have a meeting a few days ago in Cartagena. We invite around 15 countries in the region. I think that we need to advance more because Caribbean always very, very far away from us. But we need to advance in the way to generate some kind of MOU and share the information. Share the information does not mean give you your information. Share information means where I can have the information if I need it. And we need to advance in this thing. But I'm optimistic in this, and I think that Chile can play a very important role in this task.
I agree with you because I mean we have seen that the position, I mean not only for the rest of the countries in Latin America, I mean we have just had this forum of AI, I mean organized by the Minister of Science, CAF, and UNESCO, right? And we saw in the declaration of Santiago this position of Chile as a leader, this working group, okay, for Latin America. And we see also a good coordination between the European Union and Latin America as leader and Chile as a leader. So I think that I agree with you, there are opportunities, but we need to organize and we need to work a lot.
Yes, and we need to talk more between us. I think this is very important.
Rodrigo, I want to jump to you in this in the same line because Jaime, the first Jaime, talked about enabling factors that probably are more wider. I mean, with respect to AI, that is talent, right? And probably this is something more. But I'm not going to jump to talent, but not only to talent. But I want that you could tell us a little bit because CENIA, as the National Center for Artificial Intelligence in Chile, have developed recently index for AI, Latin America Index for AI. So how you see Chile there, just to answer, I mean, my friend Jaime, which is quite pessimist with respect to Chile, but how you see Chile after this study that was compared with the rest of Latin America, how you see Chile, how with respect to enabling factors and the potential that Chile has?
No, I think this one works better for the host. No. Oh, thank you, Nayada, and thank you, Inria, also for the invitation. I'm very honored to be in this panel, really. So thank you a lot. Going to your answer, I agree with Jaime when you compare with the Northern Hemisphere countries. We are, as a region, we are very, very far behind. But if you look inside Latin America, that was something that we wanted to do because we didn't, and as Jaime said, sometimes we in Latin America think that Spain is part of Latin America. Well, sometimes people in the Northern Hemisphere think that Latin America is like a big, huge country in the southern of the States, and that's not really. So that was something very interesting that we found, that the different environments around AI, considering enabling factors or research and maturity of the community and governance, it's very different in each country. It's not the same at all. So, and there are some similarities, but you have countries like Chile that lead in the index, and countries like Bolivia or Ecuador who has, in some indicators, better performance than Chile, but in the general view, they are very different. So the first finding was that Latin America is very, very diverse in terms of how the AI environment is going on. So particularly in Chile, one of our biggest strengths is actually research, as Jaime said. Like, we have today two times the number of authors that you have in the rest of, or in the average of Latin America. Our authors are 3 times more productive and they are 1.5 times more, have more impact. So we have a big community, a very productive community, and a very relevant community in terms of what they are publishing, considering only AI papers. So that I think it's very interesting. The second term that we found, it's Chile, on the other hand, has a very bad performance on the relative presence of abilities for the workforce. Like we took a metadata for LinkedIn and we worked with them to identify which skills do the workforce need for the AI in the next 5 years. And you find that Chile is behind, I don't know, Brazil, Argentina, Colombia, Mexico, and yes, these 4. So we are 5th in the region when we are leading on other indicators. And that's very concerning because when you look inside which industries or economic sectors are leading in Chile particular, you have entertainment industry, construction, professional services, and fintech. And when you look where are we behind the region, we are behind in mining, that is strategic for us. We are behind in logistics, that is strategic for us. We are behind in agriculture, that is strategic for us. So that was another finding that we found. It's very concerning because our workforce has not enough skills to get the best of AI for them and also for the economy. And at last, I want to go deeper on computing capacity because Chile has a big opportunity, quite narrow, but a big opportunity on developing an industry around GPUs and computing capacity for AI, because there's a rising awareness about the impact of AI in the environment, as the former presenter talked a little bit about climate change, but the use of energy and water for cooling the system, for making them work, it's very, very high. Today, the last estimation was around 3% of the CEO emission was because of computing capacity around the world. So it's a big issue that it's getting more and more awareness. So you can move the data centers to somewhere where you have like quite good energy, non-conventional energies as Chile, or you can move like the energy there, and it's much more cheaper to move the GPUs. And Chile has a special position because we have a very good connectivity through optic fiber cables. So one thing that we are proposing to the government is that we should encourage the installation of new data centers focused on AI, like with focused on GPUs, and to make some deal quite similar to what they have done with the observatories, like to 1% or 10% of the capacity should be available as, for example, to the NLHPC. That kind of model, because it's a huge investment that you have to make. There are a lot of relative advantages, relative advantages that I mentioned before. So that could improve and attract a lot of talent to the country that today is, I don't know, going to the States or going to China or something like that.
We have this in mic. Yeah, absolutely. I agree with you, and but it's very. I mean that's work that you did with the index. I mean, Latin American Index of AI. I mean, and it's clear that Chile has a potential to enabling and unleash. I mean, the development of AI and connect and also lead. And I want to Felipe. I mean, Felipe is leading the AI and Data Initiative in the Faculty of Physics and Mathematics in this university. I mean, I want you to connect with talent, because I understand that this initiative has to do a lot, and part of what you are doing is try to train people with respect to, and it is connected with what Jaime was saying before. How are you doing this in this initiative? How are you, I mean, seeing this, and how you think that you can connect these initiatives that today are only in the heart of the faculty internationally, and how can you, yeah? as a way to cooperate.
Thanks. I couldn't agree more with what Jaime said. We hadn't talked about this specific topic before, so I'm very surprised we agree 100%. And I want to go a little bit deeper in a few of the things he said, connecting with what you just asked. At the initiative, our main aim, I would say, is to promote the work that is being done regarding data science and AI, catalyze it here in the school and show it to the public. And on top of that, we are leading the Master of Data Science and anything that is data science in the faculty. That is our main goal. And my analysis is that to develop AI, and to develop AI both at a competitive level with respect to other countries and other communities and other regions, we need to invest first in education. But we need to invest in education at least at two levels. First, general education that I would call literacy. We need all citizens to get a grasp of how to use these tools. Just like a few years ago, we were focused on teaching students and people in general how to type. Now, probably we need to deliver a basic understanding of what programming and autonomous algorithms are. But at the same time, we need to also invest in experts that can use these these tools with confidence, know what they're doing, because something that we cannot afford is to have these very strong tools and methods in the hands of people that are not able to assess the impact of the tools. So we need to provide a solid understanding at the user level, but also at the expert and developer level. Another thing that I would like to mention that is actually very related to investing in educating the general public is to understand that not everything that can get us as a community to a higher degree of quality of life, so to speak, are based on cutting-edge AI methods. There are multiple advances that we can take as a society that are very simple technological advances. Maybe there are very simple and basic techniques for handling data that don't need super sophisticated computing resources or methods. And it's sometimes very easy to be dazzled about AI, just looking at the news and the media and other competitors in whatever subject we're working, and thinking that we need to hire the latest method to have a comparative advantage, rather than inspecting the process we're doing and start simple. Continuing with that line of thought, I want to say also that AI is a hugely instrumental tool, and by that I mean that it can be used to pretty much any purpose. But AI is not a commodity. AI needs to be developed, and the professionals that use these tools need to be developed, need to learn to use the tools. So these will be the tools will be developed and will be used and shaped by whoever wants to do it, and that is a mixture of willingness to work on this, because it's expensive to work on this. If there's a company, for example, working on agriculture, and the company says there's a system for visually identifying fruits, like the talk we had in the morning, or there's another company that has a group of trucks moving goods, and they want to use AI too. Well, the ones that are going to use and shape the tools are the ones willing to develop the tools, and the ones willing to do it are the ones that are going to have the determination to do it and the resources to do it. So, as it is a tool that is hugely instrumental, it will be promoted by anyone. And I think that, to some extent is dangerous, because in the society we live, which is extremely free in terms of developing techniques, you don't have control of the applications and the flavor of AI that you're going to be developing. And probably the direct answer to that scenario is regulation. And regulation is extremely difficult. I mean, we've been different countries and different bodies, public and private bodies, are asking for regulation. But one thing that can be done is that, even though this technique is, sometimes we say that this technique is too profitable, so it doesn't need public funding, because it's so profitable that doesn't need support. But the fact that it's profitable, that doesn't mean that public support is not a good idea, because with public support you can drive where this development is going. And I think that is the reason why it's so important to have public funding on research, for example, on this topic, because otherwise the research is going to be driven by the applications of the industry. And for that, I'm not saying that's bad, but you don't have control over it. I have a few more points, but
yeah, thank you, Diana. But you just, I mean, that your last point was a very good one, because I mean give me a point to drop in the next question that had to do with the role of collaboration and partnerships and the role of the every stakeholders. I mean, the private sector and the academy and the research institutions and also the government, right? And how in this revolution of AI is, I mean, the public funding taking really a place? Because, I mean, in these moments, probably the research of the research that is being doing right now in the modern AI has been doing in the 4 companies that are the owners of the resources, right? So what do you think? I mean, I don't want to repeat ourselves with the same answer and question and without that, because we always, I mean, have the same reflections on that. But what is the strategic recommendations? What can we done? I mean, 2 weeks ago, we were in Madrid in this 4th AI Alliance Summit. I mean, led by the Spanish presidency of the European Commission, and then it was this meeting last week in Cartagena, and now it's in Bogota, right? And there's a lot of happening in between that. Recently, you mentioned regulation, and also in Europe, you know that we have this AI Act, right? That is supposed to, I mean, it's very advanced, and I mean, it's a project that I mean, it's unique in the world, and it's very advanced, and it's supposed to be in place by the end of the year. But it seems that Europe right now, after working so many years, so 2.5 years, and this AI Act, now it's not at all convinced of this AI Act because of generative AI and because of all of these advances. On the other hand, we have China. On the other hand, we have United States with executive order. And on the other hand, we have Latin America. And we had a lot of discussion with respect to regulation and how we can, independent of regulation, how we can launch or like a regional, right, a governance, at least, you know, alliance, at least. And for that, we need cooperation between Latin America, right? So how can we envision a strategy in Latin America? And that's for Jaime, because Jaime, you just came from Cartagena. How you see things there? And if we want to ask, if we're willing to ask something to the European Union in this digital connect of digital AI alliance that is being, I mean, right now trying to build these connections between Europe and Latin America, which will be the projects or the highlights that you will be putting forward to promote this collaboration that will be fruitful for both regions?
Well, there are a lot of questions in your and there are a lot of points. One of the things, I think, the first question is why Europe is looking to us. We are a little country, how say Luis Sepúlveda, este es el mundo del fin del mundo. the world at the end of the world. But I think that we have in a moment very particular. I think there is a the geopolitics now is very, very complicated. China is advancing. China is Yankee Lithium is arrived to Chile to install a company. There is a company in Antofagasta where we construct batteries. China is advancing. For that reason, and in particular, Chile have 2 or 3 things very important. We have lithium. We can produce green hydrogen very, very cheap with respect to the rest of the world. And for that reason, Chile had a couple problems, or not problems, a couple of opportunities to develop science around these problems. And for that reason, I think that we need to profit the opportunities in this way to develop. We need to develop a new industry based in science. We cannot continue selling rocks. We need to advance with this new challenge. We are lithium, we are water, climate change. I think that there are 4 or 5 topics which appear everywhere where you go. Everybody talk about climate change, everybody talk about green hydrogen, everybody talk about lithium, what happened with the disaster in Latin America. I think these are common problems, or common opportunities, depends how you see, which appear. And I think that develop science around AI is very important in the way how we can make a more sustainable development of the industry. I think we have the mission from the science to do the things in a better way. How we can produce, for instance, without have a big problem with the water, for instance. I think in this topic, I think there is opportunity to develop science, and can put Chile in the center of Latin America, developing these areas. This is something I think.
So you will ask to the European Commission to fund applied AI, where in topics where areas we will be aligned. That's it.
Yes,
Okay.
I think that nobody give you money for nothing.
Yeah.
I don't
no, but
believe
that's
in
clear.
that.
That's clear. But you will ask for funding applied AI.
I think they are thinking. There is a geopolitical things. When I talk with the people of the delegation here in Santiago, they are really worried. Please, we are going to finance a project in lithium. But what happened with the China? China's arriving. There is a call, a tender for something. When you make a tender with the European Union, they put a line where say, principally, please, it is focused for European industries. I think that there is a geopolitics also in all those things. But this could be a very good opportunity for us.
Absolutely agree. And I mean, if we were thinking of 5 topics of cooperation between Europe and Latin America, I would say that probably infrastructure is one of them, right? Data is one of them. Okay, it's already done. What about talent and develop capacities between the regional, right? How about to fund PhDs and mobility of students and researchers and common ground projects, I mean, to develop talent at the end. What about governance of AI? I mean, for that, probably we need to align our vision in Latin America with the vision of Europe, and I mean, Europe and Latin America share a lot of common values. I mean, historically, I mean, it's easier, yeah, than to do it with China, for example, right? So Europe knows that. I agree with you that this is not for nothing, but I think that it's sustained mainly because we shared a lot of things historically, and that allow us to build things on top of that. So then that's trust, first of all. The other thing I would say is the use of AI in a way we can think of, for example, as a factor to economic and social growth. Okay, and that's your point of the applied AI to several sectors, right? And I would say, with respect, and I agree, I don't know if you comment that in Cartagena when you were there, but there was a lot of conversation with respect of the role of AI in the way, in the region, in the way we can use it to preserve the heritage, the cultural heritage of Latin America. And I think this is very important, something that we can agree in the region, and I think, I'm sure that not only Europe, but all other multilateral agencies will be happy to help on that. And the other thing that, last but not least, is gender. It's AI, gender, and the subrepresented social communities that at the end we need and needs to be represented on that. What are your thoughts on that, on these 5 priorities, and what do you, Rodrigo?
So I partially agree, I think, because I think you have to focus on something, and let me mention 3 things. The first one is that we see in the index that there is a drop on the cooperation between UE and Latin America. It was around 60% of trans-frontier papers published or conference participation or publications between Latin America and other regions. Europe was around 60% of the total collaborations in 2011. In 2020, it was 49%, and other regions as China or Middle East or even inside Latin America has increased a lot. So there's a relative loss of importance in the cooperation on scientific production between the region. And the question is why, and there's it has a lot to do with, it's much more competitive to go to Europe, because Europe it's collaborating more inside between European countries and less with Latin American countries. So Latin American authors are looking to better opportunities, for example, China for funding or Middle East or something like that. So I think that there must be done a double click inside this decrease in collaboration between the two regions. On the other hand, I'm not quite sure about. I completely agree with you on the shared values that we have with Europe instead of China or Middle East or something like that, thinking on governance of AI. But in Latin America, we have to understand that we are not Europe. We don't have the data awareness about Europe that Europeans have, or the robust bureaucratic states and regulations and history and culture about these things. So from my point of view, trying to mimeticize with the UA Act, that I think it's a very good work, it's something that will not work for Latin America. In the case of Latin America, you have to understand, we have to understand that we have local idiosyncratic ways on regulation that if you want them to work, you have to think them from Latin America. And one thing that I think is very important is that we cannot have something so horizontal as the UAEA Act, because it's transversal to every industry and every aspect of the impact of the AI. So from my point of view, you have to go to something more vertical on regulation, like to identify some sectors that you think, okay, in this sector AI can have a huge impact, and to regulate this sector specifically. Different health from education and different education from workforce or something like that. Because that has most to do with our idiosyncrasy and also with our position as takers of the technology and not developers of the technology. When we go further and become developers, I think that's the point where we can go through a regulation that is more wider and not so narrow. But I think, considering the state of art today in Latin American countries, we have to focus on that way. And at last, where can we cooperate more? I think I agree with what Jaime said, and I think something that should be very helpful for the development of AI in the region is the building of better and bigger data sets from Latin American data. Like language models or health data sets, or this project, Guacamayo project that they have with Microsoft in Colombia or Peru or something like that. That kind of project, like big scale, big money for getting more data, public data, that's something that can work and keep and save our culture that it's getting lost with these large language models. So that's my thoughts on that.
I tend to agree with Rodrigo, most of the comments. I think, I don't know if I know quite well Latin America. This is my main problem. I know a little bit my country. I know a little bit the idiosyncrasy of Argentinians and Brazilians. But I don't know Peru. I don't know Ecuador. I know a little bit Mexico. And all of them are quite different. We speak more or less the same language. Even with Brazil, we can communicate quite easily. But we're different. We understand each other, okay, yes. Probably it's not as different as a German and an Italian, but after so many words, maybe you got together, finally, in Europe. I don't know. I cannot speak for Latin America. Sorry. I can speak for Chile. And if we have a hope, it's because we have a strong tie with some countries in Europe for culture and for history, Spain, of course, but mostly in science with France. So if we have a small, quite productive group in math and some related areas, it's because of collaboration with France. 40 years ago, Chile produced 0 articles. 0. I entered to this university and my professors produced 0 articles. And they were the first generation that went to Europe, to France, most of them, and returned. And they started producing in the 80s some articles. Today, we are the most productive group in Latin America by numbers. So we produce 1/3 of Brazil in volume. This is unbelievable. Brazil has a history of 100 years of math, I guess. They are 200 million people. And we're a small group, so productive. And this is because France. Nothing else, France. And in France, the French people, they are so generous. And the institutions, they are so generous with Chile, CNRS and Inria. It's unbelievable. So this is the only hope we have to get developed. Continue to that collaboration. Centers like Inria that installed in Chile, you could have installed it in China. Why you choose Chile as the first place? Come on. We thank for that. We thank for that. Myself, I studied in the United States, but in the last 30 years, I spent 10 years in France. I counted that. So I feel like a little bit French, if you allow me. This is not the first time we have this big opportunity. We have that opportunity in the late 90s with modeling, in the late 2000s with data analysis, after machine learning. Now it's in artificial intelligence. We don't have the people to do that. We have to invest in people. We have a long way to be a major player, not in the world, in the region. When a technological industry installed in Chile, say Amazon, whatever, you choose. The CEO they put in Chile is from Chilean? No, it's from Brazil, come on. is always from Brazil. The most developed part of Latin America is Sao Paulo, and everybody will agree on that. Sao Paulo is a piece of Europe or the United States in Latin America. You have 1,000 industries from Germany installing that there. So when somebody installed a technological industry in Chile, the CEO is from Brazil, and they deserve it. But the second one is from the one that is expert woman or man in technology is from what country in Latin America? Argentina. Argentina is a disaster, will say a Chilean. Come on, come on. Argentina has, from the educational point of view, is ahead of us, I don't know how many years, in the population. Look at the way they speak. That's the only thing you should listen. And so we have a long way to go. And we need to be tied with Europe and France, CNRS, Inria. Please, stay in Chile.
Hi. I didn't quite answer your question about how we collaborate with Europe, and it's a hard one. So after listening to the other panelists, there are two things I want to mention. I remember a few years ago when I was reading this the French AI report, the one that was written by Villani, I guess. I'm not sure if the current version is the one I read, but it was beautifully written, and it started with something like the people of France was worried about these developments in AI that will relegate us, the French, read the text, as observers in the development of this technology and at the will of the big players developing these techniques. And I to this day I think if the French were worried about that, so what's left for us? But at least that is a common fear, and sometimes it's good to be motivated by fear. With that, I want to stress the importance of the technological independence of the countries, because we are living in a world that is so global that, and especially for this technology, there's no cost in transporting the technology. Something that is developed the other side of the world immediately becomes available here, and any product that is developed anywhere, we automatically become clients for the product. So how do we protect ourselves to be relegated as customers of whatever is developed? And for that, we need to strengthen our identity. That is something that we need to do in Chile, not just in this realm. In the sense of being producers and not just consumers. And that is something that we share, at least with that document I read, or that part of the document I read for the French AI policy, I think it was the name. The other thing is, it is very clear, and Jaime just mentioned it, how we have taken advantage of the relationship with France in terms of development of our industry and academia. And we are not ashamed of asking, as Jaime just said, but I am wondering, what can we offer to France? I think that is a valid question to ask ourselves, to achieve a balanced relationship, a virtuous cycle where we both win. And it not just out of fairness, but also out of stability. So looking each other as equals in a partnership. So the question I couldn't answer, I turn back to you. as representative of Inria. So what can we offer?
I forgot to mention something. We are so few in Chile that the only possibility we have to develop is through collaboration with other countries, specifically to Europe, but collaboration among the Chileans. Sometimes the shortest path between two Chileans pass through Paris. And this is something that we have to fix. What we can offer to the French people and institutions, well, friendship for us is very important, and from French I know it's very important. But also a couple of, at least two big topics in the world. Climate change, and Chile is a wonderful laboratory for that. From the ocean, and we have a different type of climate, etc. And we have a community that works. We are collaborating with that in Inria through different projects. And maybe there is another topic, energy. So Europe needs energy, and we can produce a lot of energy, probably. So those topics are, I think, good enough to have a deeper collaboration.
Astronomy?
Astronomy, of course. But this is nothing to do with Chile. This is something that is done with the nature of Chile, no? But we have a strong community also.
Well, I mean, it's a pity that we don't have enough time to keep talking, but next time I will organize like a croissant café. Croissant café?
Café croissant. That's better.
To discuss more relaxed and all of that. But I just wanted you to provide like a very last tweet, because I kept like with some messages from here. Data, governance, talent, people, education. I want a message from you. Yeah.
Computing capacity.
Computing capacity, education. You?
We need certainly computing capacity, education.
Felipe?
You just took the two important ones. Yes. I'd say, okay, after those two, I'd say social awareness. So we have many problems as a society, and AI can amplify them. So let's focus on the problems of the society and not the problems of the AI.
I say collaboration between us. More croissant café.
Absolutely, and we finish with this message of collaboration between two regions and France and Chile, and I hope we can make the most of it. Thank you so much for being here. Well, I'm going to do something different today, so I want Jose to take a picture of the panel, like stand, please. Well, I'm going to give all of you, I'm going to do a little stand-up. No, that is a joke, a really bad one. So thank you very much to the panelists, to the author. Don't leave the room. I have a surprise for you. Okay? So for all of you that stay that long with us, so my words first and then the surprise, okay? I have your attention? Yes? Okay, good. Mientras que yo continúo entreteniendo a la audiencia. Yeah. So, thank you very much to the panelists, to the authorities, and to all the participants, you, who brought life to this second day of the Journées. We remind you that tomorrow we will meet again at 9 a.m. at the Salón de Actos, Building T, Casa Central, Universidad Federico Santa Maria, in case of any, all of you that you can go there.
we will have another exciting day filled with essential scientific conversations. See you tomorrow. Thank you very much. And now I want you to invite all of you to take a nice picture here. So that is a surprise. I hope to please bring your best smile and playful attitude. You can ask the artificial intelligence how to pretend to have that smile. Thank you to the good Jaime, the bad Jaime, Nayat, Rodrigo, and Felipe. Aren't they good looking? Yes? Okay, come before I keep saying, yeah, here. Or si yo creo que no alcanzamos a poner el
Ese que como adelante, como el mismo lado. Con ese mismo
¿Dónde quiere? ¿Lo pongo al lado allá?
Caminando adelante, por favor.
Desde acá. Ya. Inria.
Un segundo, por favor.
Desordenado.
Hacia ese mismo.
Eso, mantenemos ojo de pez.
Dios, se quedó pegado.
Ahora cuando desordenado. Por eso. Súper desordenado.
Sí, bueno.
Hagamos.